audible to all of you? Will anybody confirm?
Yes, sir, you are audible.
Please unmute and just confirm I'm audible to all of you.
Yes, sir, you are audible.
Bakshi sir is done.
Yes, sir, Bakshi sir is there.
Okay, thank you, thank you.
Then we still have 2-3 minutes, so we can wait for the time being.
Yes, sir. Yes, sir.
Participants join.
Good morning, everyone, and good morning, Professor Bakshi sir. Welcome again.
Good morning. Good morning. Because we have still 35 participants, so I thought let's wait for a couple of minutes.
Let's wait.
Because in the morning there is a possibility people get delayed.
I was also on way. Let me just join to welcome you and all the participants.
Okay, you're on way. Okay.
Hello. Today, Dr. Anwar's duty is there, huh?
Yes,
Oh.
madam.
Morning. Okay.
Shall we begin or wait for a few minutes more? Now there are.
I think we can start, yeah.
Yeah, 45, around 40 members are there. Okay. Shall we, I will begin now, madam.
Oh, sure.
Thank you, sir. Good morning, one and all. On behalf of organizing team and the mentors, myself, Dr. Anwar Sheikh, welcome you all on the 8th day of this online refresher course on chemistry, Future of Chemistry. Started from 21st of September, ending till 5th of October 2024, and which is organized by Shri Guru Tegh Bahadur Khalsa College, University of Delhi, under Malviya Mission's Teachers Training Program. Today's first session is on digital transformation in chemistry that will be conducted by Professor A.K. Bakshi. Bakshi sir has already conducted the previous sessions. So with a brief introduction of Dr. Professor A.K. Bakshi, he is a founder Vice Chancellor, PDM University, Bahadurgarh, former Vice Chancellor, UPRTO University, Allahabad, and former Executive Director, Tertiary Education Commission, Mauritius. I'll invite sir to begin with the session. Thank you. Sir, please.
Thank you very much, Dr. Anwar Sheikh, for your kind words of introduction, and Professor Vimal Rar, and all the other participants. I extend warm greetings to all of you on this 8th day of this refresher course. And today I will be speaking on digital transformation in chemistry education and research. Because, the theme of this program is future of chemistry education. So what the future of chemistry education is going to be, all that would come under this category. So before I start, let me share my screen. Dr. Sheikh, is my screen visible and am I audible?
Both are perfect, sir.
Okay, thank you. Thank you very much. So this is the title of my talk, Digital Transformation in Chemistry Education and Research in India, an overview. So this is a very important talk because it will cover, how technology has changed the way chemistry education is imparted now, and how chemistry research is conducted in India. In both of things, we will talk about the impact of technology. And then at the end, we will talk about what all is going to happen in this context in future. So we will talk about present status and also the future of digital transformation. So that's the main purpose of this talk. The structure of the talk, as you can see, it is in 3 parts. First, I will talk about introduction to digital transformation and its importance. Why we are so much concerned about digital transformation, all that will come here. Then in part 2, I will talk about the impact of ICT on chemistry education and research. If you remember, I have already talked about ICT empowered pedagogies in my last talk. So I will not be repeating that. So here, how other aspects of chemistry education and research have changed, that will be covered. And then in part 3, what is going to happen in future? What is the future of digital transformation? So that will be covered in this part. So let me now start my talk. I will start with very basic. So please excuse me if I am trying to be very elementary. I will introduce technology, digital transformation, and digital tools. So what is technology? See, technology in simple language is the application of scientific knowledge to practical use in human life. That is the simplest definition of technology. Application of scientific knowledge to practical use. And the scientific knowledge is growing day by day. Therefore, one could say that the science of today is the technology of tomorrow. And therefore, technology would also be evolving every day. So this is something you have to keep it in mind. Then, a few things you have to remember, that technology is only an enabler which can help you achieve the intention of the person who is using it. Technology doesn't have a brain of its own. And then technology makes our lives easier and more convenient and helps us to do things more quickly and effectively. So why not use it in education also? So these are the two things you have to remember. Now, the technology which we are talking about here is information and communication technology, ICT. Now, what is ICT after all? See, ICT is an umbrella term that encompasses all communication technologies that provide access to information. So you can see it's a very broad term. Internet, wireless network, satellite communication, cell phone, digital TV, all come under ICT. The common feature is ICT processes information and aids communication. This is the common thing. And then ICT is just a subset of technology. There are many other types of technologies also. That also you have to remember. Every technology is not ICT. Therefore, here we will be focusing on ICT in digital transformation. Now question comes, what is the meaning of digital transformation in our higher education? See, digital transformation in higher education means the transformation brought about in higher education as a result of integration of technology with it. See, higher education was being imparted earlier also. It's not something new. But here we are integrating technology with higher education. And the result is digital transformation. Normally, it would have taken a lot of time to achieve all that. But COVID-19 has sped up this process of digital transformation. What could have been achieved in 10 years was achieved just in 1 year during Corona times. See, we all became tech savvy mainly during that time. And that's why, digital transformation has become so popular and important. So the next question which could come to your mind is, how do you integrate ICT with education? This integration of ICT with education is done using digital tools. These are the tools, which help in the various tasks involved in integration of technology with education. They help in making these tasks easier to complete. So ICT on one hand, education on the other hand, and the integration is done using digital tools. These are some examples of digital tools. You can see interactive whiteboard, word processing, MS Word, PowerPoint presentation, electronic reference material, video recording and editing apps, video conferencing app, including this Zoom, Google Meet, Cisco, all. Then learning management system is also a digital tool. And then various audio tools. So these are all examples of digital tools. Through them, we are able to integrate technology with education. Here, before I move further, let me tell you very briefly the history of integration of ICT with higher education in India. There have been 3 major milestones in the integration of ICT with higher education in India. These are the 3 major milestones. On the left side, you can see in the year 2006, Sakshat portal was launched by the government of India. And as you can see in the picture, this is the time when it was inaugurated by Dr. APJ Abdul Kalam. And the main purpose of Sakshat portal was to leverage the powers of ICT in higher education. That was the beginning. I was the chairman of the Content Advisory Committee in Chemistry under Sakshat portal. Then came NME ICT in the year 2009, National Mission on Education through ICT. Here, the main focus was on developing multimedia, e-content, then high-speed connectivity, then low-cost access devices there was a focus on these devices, and then various educational channels were launched during this period. That was in the year 2009. And then came Digital India, which started in 2015 under the present government. So you can see that there is a long history behind integration of ICT with education in the country. But one thing you should only keep it in mind, that ICT has only changed the way education is imparted in the 21st century. Education remains the same. Goals of education remain the same. Only thing which has changed is how education is imparted in the 21st century. And the goals of the education, you all know, are these three: to produce good human being, a responsible citizen, and a competent professional. So, you can very well understand only the way education is imparted has changed. And even we will see later on, there are so many problems in the education sector. Solutions to them are also found in digital transformation. That is another big thing. And these are the major benefits which we have as a result of digital transformation. Access to higher education has increased. Quality has improved. It's possible to have learner-centric education, experiential learning. Then education can be now imparted with equity. And then in many universities and colleges, there is a problem of shortage of competent faculty. That problem is also overcome. Problem of infrastructure is also overcome. So these are the main benefits of digital transformation in higher education. And you would see, and I'm very sure you all know, ICT, if it is used creatively, can make a big difference in the way the teachers teach and the students learn. And that is the future of chemistry education. That is why, we have chosen this theme, chemistry education future, because the way we teach, the way students learn, everything has changed. Because of ICT, the various innovative pedagogies are now possible. Other day I talked to you. Problem-based learning, project-based learning, collaborative learning, flipped classroom, all they are possible because of digital transformation. And this slide summarizes the entire digital transformation which we have seen in chemistry education in the country and research. This is the present status. This is a very important slide. Teaching learning has changed. E-learning and MOOCs are becoming very, very popular. PowerPoint presentation, video clippings, audios, all they are part of new style of teaching learning. Chemistry experimental work is done using virtual labs now. It's possible. Then revision of the syllabi you can do very fast using ICT. For research, so many tools have come which help you in doing research much better. The way research is conducted has totally changed because of these tools. Electronic databases have come which help you in the literature survey. Assessment. I will talk about assessment later on separately, but online exams are becoming very popular. National Testing Agency has been created. And then professional development of the teachers. ARPIT program is very popular. And then ICT empowered pedagogies, which we have already talked about. So you can see how digital transformation has changed the way chemistry education is imparted and the way chemistry research is conducted. So this is a very, very important slide which summarizes everything. So in this talk, we will be focusing on chemistry education and research. So now I come to part second, where I will talk about impact of ICT on chemistry education and research. So this is part second of the talk. And here, the first thing which I will talk is e-learning and MOOCs in chemistry. This is a new thing which has come. You all now are familiar. E-learning and MOOCs. Now, what is e-learning? E-learning basically means electronic learning. Focus is still on learning, only the mechanism has changed. So e-learning is a learning that uses ICT, information and communication technology. And then what are MOOCs? MOOC is a very popular e-resource which facilitates e-learning, but in a very structured manner. See, this word MOOC was coined long back in the year 2008 by Dave Cormier. And these MOOCs became so popular in United States in the initial stages that the year 2012 was declared as the year of the MOOC by the New York Times headline. Because they totally revolutionized the way education is imparted. Now, what is a MOOC? MOOCs is basically an e-resource. And what are e-resources? E-resources are basically materials in digital format, which are accessed electronically. All these are e-resources: MOOCs, courseware, open educational resources, e-books, e-journals, e-zines, e-newspaper. Everything comes under e-resources. They are all in the digital format and they are accessed electronically. And now what is MOOC? MOOC is an acronym for Massive Open Online Course. You can see Massive Open Online Course. Why we call it massive? Because there can be unlimited enrollment. Lakhs and lakhs of learners can enroll in a course. We call it open because no qualifications are required to enroll until and unless you want to obtain the grades. Then MOOC are offered online through web. And then course. Normally one semester paper is taken as one course. So that is the meaning of the MOOC. And the basic philosophy of MOOC is 4 A's. You can enroll in the MOOC anytime, from anywhere in the world. Anyone can enroll, and one can learn from MOOCs as many times as you want. So these are the big advantages of the MOOCs. And the biggest advantage is that one can decide one's own pace of learning. Whenever you find time, you learn from the MOOCs. You have to just go to the site. And then these MOOCs are highly economical. What all you need is maybe a laptop or a smartphone or a tablet and internet connection. That's all. So you can see how MOOCs have changed. This is very, very important. Basic philosophy of MOOC is this. So MOOCs can be considered like big classrooms on the internet where lots of people can learn together. That's a very simple and a common man's language. Now the question is, what is the basis of MOOCs? How do you develop MOOCs? The basis of the MOOCs is e-content, electronic content. We also call it digital content. So e-content is the content or information delivered or made available using computer networks such as internet. So this is the content which is delivered or which is made available using computer network. And when I say e-content, it includes text, videos, audios, animation, and graphic. Everything can come in the e-content. And then how do you develop e-content? This is the steps in the development of e-content. You should all know that. Because country is developing so many MOOCs, you should know. And tomorrow you may also like to develop that. Suppose you have a 4-credit theory paper, which is normally covered in 35 to 40 lectures. So you divide the syllabus of this 4-credit theory paper into 35 or 40 parts. Take one part at a time. Then you develop static content for that part, which is developed by subject matter experts. We will call this one module. So you develop the static content. Static content means for that portion of the syllabus, you write text, you write value addition, quizzes, graphics, images, etc. So that is called static content. Static content is something which can be printed. All this can be printed. After the static content has been written for that module, then you do the multimedia enrichment of that content. What do you mean by multimedia enrichment? Wherever required, you add audios or videos or animations or simulations in order to make the content interesting. And the result is e-content per module. So e-content is nothing else but multimedia enriched static content. And these are the steps. So you can see how this is for one module, then you take the second module, third module, then you develop for the whole paper. And then we arrange them and we call it a 4-quadrant format of MOOC, which is very popular. This has been developed by our center. Each module will have 4 quadrants. One will be quadrant 1, where we have video and audio content. Quadrant 2, where we will have e-text, value addition. Quadrant 3 will be discussion forum. Quadrant 4 will be assessment and questions and their answers with feedback. So far, one 4-credit paper, 35 to 40 modules are. So total number of quadrants will become 140 to 160. See, why 4 quadrants are required? You may ask the question. 4 quadrants actually means, you can hear something, you can see something, you can say something, and you can do something. And as you can see, 90% adults retain 90% of what they hear, see, say, and do. That is why 4 quadrant is expected to do better. In our printed books, we are only able to see. That is just 30%, as you can see, retention rate. But here, there are some videos also, there are some audios also, there are some, other value additions which you do that make it the retention rate much, much larger. So what makes a good quality e-content is that it should have all those features which make self-learning exciting and interesting. That's the purpose. Only then the MOOC will become interesting. And it's a massive team effort. It's not very easy. For example, look at how this animation helps you. Just watch this.
It's scorching heat and a person is really thirsty. He is willing to pay a good amount to get thirst quenching 1 glass of water. This is because he is getting immense benefit from this 1 glass of water. From the second glass of water, the additional benefit he derives is a little less than the benefit from the first bottle. Hence, he is willing to pay a little less for the second one. The economist's term for this additional benefit is marginal benefit. And so he derives even a little less benefit from third glass and would pay even lesser. This explains the law of diminishing marginal utility.
So you can see how the law of diminishing marginal utility can be so well explained through this animation. So that is the strength of, multimedia enrichment. And ultimately, the structure of the MOOC is like that. You can see 4-credit paper, 1 semester, 35 to 40 modules. You cover it in 15 weeks. Overall duration is 40 hours. 20 hours of that will be videos. And you can see on the right side, First 7 weeks, some modules will be covered. Then week 8 will be revision and assessment. Week 9 to 14 will be the remaining MOOCs. And then week 15 will be revision and assessment. So that is how a MOOC is offered and students learn in this way. And in our country, there are so many programs, so many courses. So development of MOOCs in India has been divided. This task has been divided amongst various national coordinators. For example, NPTEL develops MOOCs for IITs, for engineering subjects. NPTEL, a group of IITs and IISc. UGC has developed MOOCs for postgraduate disciplines. The CEC, Consortium for Education Communication, has developed MOOCs for all undergraduate programs. IGNOU for some diploma and certificate courses. CBSE, NCERT, National Institute of Open Schooling, they have developed MOOCs for 9th to 12th standard. And then others. So you can see it's a well-planned exercise where various national coordinators have been given the task of developing MOOCs. And all the MOOCs which are developed in India, they are hosted on the SWAYAM platform. You can see this. This is a technical platform. This is the learning management system. All courses are there. You go to this site, you will find all the courses. And learning management system, you all know. Even my class you are using, that is also a learning management system. It is able to track learning, testing, registration, uploading material, communication, delivery, and course material. All that comes under LMS. And this SWAYAM platform is unique because it offers you the advantage of anytime learning, ATL. Just as we have ATM for bank money. So this is a very big advantage of the SWAYAM with respect to MOOCs. So anytime learning, this is something you cannot expect from your physical classroom. So anytime learning is the unique advantage MOOCs offer through SWAYAM. And this SWAYAM is one of the world's youngest MOOC provider, largest. And these are some characteristics of the MOOC. SWAYAM platform. It is one of the world's largest MOOC provider. Already more than 3,000. Now I think it's even 4,000 courses have been uploaded on this platform. $33 million investment has already been made. Then there is an introductory video or summary for every MOOC, which explains the overall content of the MOOC. And then all MOOC courses are free. But if you want to appear in an examination and want to obtain a certificate, there is a nominal fee. And then the courses are flexible. You may not need to go through entire course. You can go through the requisite modules as per the syllabus. And they are very useful for the teachers, young teachers. In your own subject, you can learn from the MOOCs. And you can see from the video what is the content of the MOOC. For example, we have developed so many MOOCs in our center. I have developed MOOC in chemistry. This is the introductory video of my course. Just see for a minute. Dear students, welcome to this MOOC on quantum chemistry for postgraduate students. This MOOC, which you are required to complete in 15 weeks, has been developed in a very systematic and logical manner. In the first week, you will learn about the fundamentals of quantum mechanics, such as what is quantum mechanics, how did it originate, what's its role in chemistry, and how does it operate, etc. This will be followed in the second week by a detailed discussion on the role and properties of operators in quantum mechanics and the complete solution of the particle in a box problem. In the third and fourth weeks, we will solve Schrödinger equation for a rigid rotator and a linear harmonic oscillator respectively. After these model studies, in the 5th and 6th weeks, we will take up the simplest chemical system, that is hydrogen atom, and will solve Schrödinger equation for hydrogen atom. The 7th week of this MOOC will be devoted to the concept of angular momentum and its relevance in quantum mechanics. The 8th week shall be a revision and assessment week for you. In this week, you are supposed to revise what all you have learned over the past 7 weeks. We will give you assignments which you are required to submit in time. Please note that the marks obtained by you in these assignments will count towards your grades in this MOOC. In the 9th and 10th weeks, we will focus on approximate methods of quantum mechanics. Here we will focus on perturbation theory and variation method and discuss their simple applications in quantum mechanics. The electronic structure of molecule, angular momentum and its relevance equations. Will also be again a revision and assessment week for you. Here also you will be given assignments which you are required to submit in time. Please note that after the completion of this course, there shall be a proctored examination about which you will be notified at appropriate time. Dear students, I'm very sure that you will find this course very interesting and enjoyable. Please go through the entire e-content, which includes self-learning videos, e-text, and learn more, etc., very thoroughly, and also perform the various activities and assignments of this course sincerely. I'm quite confident that going through this MOOC shall be a great self-learning experience for you. I wish you all the best. So you can see how this MOOC, this is the introductory video which tells you about the content of the MOOC on quantum chemistry for MSc students. And this was recorded a few years back. So that is for every course. There is an introductory video. That's what I really want to tell you. And if you look at our MOOCs on SWIME platform, these are some of the most popular MOOCs. Computing with Python, ethical hacking developed by IIT Kharagpur, programming in C++, like that. And this SWIME platform has been designed to achieve the 3 cardinal principles of education policy. What are those principles? Access, equity, and quality. This helps you. This is a very big achievement on the basis of this SWIME. See, MOOCs can help you in increasing the gross enrollment ratio in the country. Currently, our gross enrollment ratio is about 27%. NEP 2020 has set a target of 50% by 2035. So this can be done with the help of MOOCs. You cannot do it physically, because if you try to do it physically, you will be needing 3.3 million more teachers. That will become very difficult. So you can see this is an immediate benefit of MOOCs in enhancing our access to education. Then, National Digital University we are going to have very soon in the country. And this National Digital University is based on the hub and spoke model of National Digital University. This is the model. Hub will be, this SWIME platform will be the hub. And Samarth will be the governance platform. So all the courses, all the MOOCs which are on SWIME, they will be used in this National Digital University. And the advantage is, you can say why people will go for digital university. Just think, there are unlimited seats per course. There is a minimal eligibility criteria, affordable education, very cheap, flexible learning, large variety of courses, and then you may be getting education in your mother tongue. These are the reasons why you should go for digital university in future. And now, UGC has come out with these regulations that any student can enroll in up to 40% of the courses per semester through MOOCs on SWAYAM and earn credits. So you see how education scenario is changing in the country. And this is in all disciplines, including chemistry. For all undergraduate, postgraduate courses, now 40% of the courses you can do through MOOCs. So it's a sort of a revolution which is now coming through online education. That's something you have to remember. And if your students are enrolled in MOOCs, you can still help them. How you can help your MOOC students? By engaging in discussion forum. Conducting live question and answer session you can conduct if they have some queries relating to the MOOCs. Providing feedback, sharing resources, tracking their progress, offering personalized support, and fostering an inclusive, interactive learning environment. Now, these are going to be the new roles of the teachers. For example, I told you about quantum chemistry MOOC. If student is enrolled in quantum chemistry MOOC, and if a student has some query, the teacher of physical chemistry who teaches quantum can help the student through all that. So this is the new role. And then, MOOCs have been developed by the renowned professors of the country. It is something like the best of the country addressing the rest. And then MOOCs help you in realizing the dream of lifelong learning. You can enroll in any MOOC. For example, I am a student of chemistry. If I want to learn economics or international politics or international relation, I can learn from those MOOCs. And then high quality education is available to the masses. We have school level courses, we have undergraduate courses, we have PG courses, all developed by top experts. So high quality education is available to the masses. And that also with equity. You can see this is equity. So, these are the things which you have to keep it in mind. And then MOOCs make learning learner-centric and interactive. And just one click away, you go to the button and then you are in that MOOC. And very recently, something new happened. This is the launch of SWAYAM Plus platform has also been launched by the government of India. SWAYAM Plus. This is operated by IIT Madras. So this SWAYAM Plus platform actually hosts some industry-relevant skill-based courses. This is a new platform which has been launched, hosting skill development or industry-relevant courses. Basically, aim is to boost employability. And then, most of these courses are in multilingual content. And these have been developed in collaboration with some of the leading companies of the. So this is a new development. And then, these are some of the most popular MOOC platforms in the world. You should know edX, Coursera, Udacity, Khan Academy. These are the world's top 5 MOOC providers. Just as we have SWAYAM, these countries also have these MOOC providers. And what are some of the most popular MOOCs in the world? One is on machine learning, that is very popular. On Coursera, developed by Stanford University. Then the science of well-being, learning how to learn. This is a very popular MOOC, learning how to learn. And then you can see at the bottom, introduction to public speaking. That is also another very popular MOOC. So you can see how the world of MOOCs has changed the way education is imparted now. That is the message which I wanted to give you here. However, there are some challenges in the development of MOOCs. That also you should keep it in mind. If you want to develop MOOC, they should be of high quality, authenticity, and interactivity. And in the development of MOOC, you need a proper coordination between academic and technical teams. Because academic team may not be knowing the technical work, technical team may not be knowing the work of the subject matter expert. So they need to be having a proper coordination. And then MOOCs need to be developed in a time-bound manner. You cannot take years and years to develop a MOOC, and by the time MOOC is developed, courses have become outdated. That should not happen. And then, multilingual content is also very important. Most of the MOOCs on the SWIME are in English. They need to be translated into various languages. So what I want to say is that if you want to develop MOOC, or if you want to develop e-content, you need to have a full understanding of the topic. You should be a great teacher with excellent writing skills. Because, you have to develop various modules. They need to be arranged in a very systematic and logical manner. Language should be simple. There should be a clarity of expression. And then you should have the ability to come down to the level of the students. That is what we need as a good teacher. And even I would say, all of you should have an understanding of science of learning, how students learn. So you should have a full understanding how students learn and then connect it to the practical implications for teaching. So how does learning take place in the minds of the students? Let's try to understand the science of learning. See, learning is what? Learning is about gradually inducing changes in learners' actions and behaviors. And learning process is always incremental. Slowly, stepwise, you learn. It induces changes in your thinking and mental models, and through deep understanding and conceptual strengthening. That is how you learn. And after each learning, the learner tries to apply the acquired knowledge in practical situations in life, profession, or workplace. So you learn something, you apply it to real life situation, and then you become more confident. So, teachers need to be massively retrained and oriented for online teaching learning mode, including development of MOOCs. It's not very easy to develop MOOCs, but MOOCs are going to be there for years to come. Therefore, all this is very much relevant for you. This was my article on SWIME platform in Education Times. Will SWIME transform the quality of faculty in higher educational institutions? So this was e-learning and MOOCs. Now I can talk about how ICT can also help you in the revision of chemistry syllabi. Although a small thing, but it saves you a lot of time. See, the knowledge actually in all disciplines, including chemistry, is growing very, very fast. So fast that the doubling time of the growth of knowledge has shrunk considerably. Shelf life of chemistry knowledge is becoming shorter day by day. Look at this. Chemists are the people who produce new substances in the labs. So there is an exponential growth in the number of chemical substances. Currently, we have about 80 million. By the end of this century, we will have 5 billion chemical substances. Just imagine. Then the number of elements in the periodic table has increased up to 118. That is another indicator. These are the new elements. Then, many new instruments, modern instruments have come. Then many new ideas, concepts, theories are emerging on the chemistry scene. And because of that, so many subdisciplines of chemistry have emerged. So all this indicates that chemistry knowledge is growing very, very fast. And therefore, you should also keep it in mind that what you know is merely a drop and what you do not know is an ocean. And therefore, we need to revise syllabi more frequently. This is a very relevant point. Sometimes I feel our syllabi have not been revised for years. Even at school level, still we teach the same thing. And here ICT can help you. ICT can help you, it can provide you a platform for the periodic revision of syllabi through email, discussion forum, video conferencing, etc. See, there was a time when revision of syllabi used to take years and years, but not now. So see, ICT is helping you. Then, ICT can also help you in chemistry research. Research is something, which we neglect. This is my feeling. So how ICT can help you in chemistry research? See, just a few minutes I would spend on basics. What is research after all? Research is the art of scientific investigation. It's the search for knowledge. That is the meaning of research. And research, this paragraph explains many things. Research is the process of finding out new things and understanding more about a topic by asking questions, collecting information and analyzing it. It's like you are a detective trying to, discover facts and solve mysteries about how things work, why they happen, and how to maintain them better. All this comes under research. So there is a reason why do we do research. These are the reasons. Knowledge, and for you do research for knowledge and understanding. You may be doing it for discovering and verifying new facts. You may be doing it for supporting truth and proving lies. You may be doing it for developing new scientific tools and technologies and aiding business. All are the motives. These could be the motives behind doing research. But in India, quality research is the need of the hour. This is my message to all of you. You are all young. We need quality research. This was the report that 99% of the higher educational institutions in our country are not contributing to the country's high quality knowledge creation. 99%. They are doing just routine research. Emphasis is more on quantity rather than quality. So you can also do the introspection. What type of research you are doing? Because you need it for promotion, therefore you publish papers. That's not the purpose of quality. That's not the purpose of research. And if you look at India's performance in research, this is very interesting. India ranks 4th in the world for research, 9th for highly cited papers, and 10th for patent filings. But the number of researchers, research capacity in India is very low. We have just 250 researchers or scientists per million of the population, which is the lowest even among the smaller Asian countries. India ranks 40th in the Global Innovation Index. There is a low research capacity. Gender gap is also there. Women scientists are very few. And then only 0.5% of higher education students are enrolled in PhD. After doing MSc, only 0.5% of the higher education students are enrolled in PhD. This is the performance. This is the facts. And the biggest problem in research in India comes from lack of adequate funding. You don't have enough funds. For the last so many years, India has been spending about 0.6 to 0.7% of GDP on research and development, just 0.6 to 0.7%. Private sector is not coming forward because they think there are so many risks involved. Why should we invest our money? And then, you will all agree that leaving aside very few institutions, most of the institutions lack modern laboratories, equipment, and resources which are necessary for cutting-edge research in the country. So you can see where we stand in research. These are the shortcomings. But please remember, quality research propels humanity forward. It is necessary for the growth of the society. And this quality research is fueled by intellectual curiosity. Why I should do research? Because, one thing you should always remember, without research and curiosity, the world will slow to halt. Nothing will progress if there is no research. And for this quality research, quality education is very important. This is why I am wanting to spend this time. You are all imparting education to our students. See, if today we are not able to do quality research, one of the reasons is the quality of education imparted to us. Because, strong foundations for quality research are laid during imparting or receiving of quality education, even in chemistry. If your chemistry education is of very high quality, it will help you in producing high quality researchers. And when I say strong foundation, it means in-depth understanding of the topics. Many students, I see many students, many teachers, they lack this in-depth understanding of the topics. They have been teaching a topic for years, but still they lack that in-depth understanding. They lack, understanding of interconnection of topics. Clarity of concepts is not clear to them. These are the reasons. And all this is because of poor quality of our research and poor quality of our education. See, that was the reason why recently in Rajya Sabha, it was mentioned that the best of the science students are going to civil services. Our best of the science students coming from engineering, medicine, or science, they are going to civil services, IAS, IPS, etc., and not for research. These are the reasons. And these are the challenges for our education system. This is for all of you to have. We have rote learning focus. We have to change that. Our curriculum is very rigid. We follow teacher-centric methods, talk and chalk. We have exam-centric teaching. Oh, this will not come in exam, therefore let me not teach you. Then inadequate teacher training. Teachers are also not trained sufficiently. There is a poor industry-academia collaboration. Because, we need to nurture innovation and creativity in our students. And this is one slide I prepared. This is very important for each one of you. What all one needs to excel as a researcher. You can look at it and see whether you have all these qualities or not. This is very important. First is field-specific knowledge. You should have deep understanding of research area and up to date with recent advances. Whatsoever may be your area of research in chemistry also, there are so many possibilities. Deep understanding of research area and up to date with recent advances. Literature survey you should have done. This is the most important thing for research. Second is you should have creativity, analytical and critical thinking skills. Then you should have technical proficiency, ICT tools, software, information literate you should be. Ethical integrity. Then you should have strong communication skills for writing research papers and presentations. Your skills should be very good. Then you should have collaboration and networking skills with other researchers and institutions across the country so that you can network with them. And then time management also, you should have this skill, deadlines. If you have some project, deadlines have to be met. And then perseverance and patience. What does it mean? Even if some failure occurs, you should bounce back. Resilience should be there. See, these are the qualities which a researcher needs to have. This is very, very important. This is my life's experience I am sharing with you. I have worked with the Nobel laureates. I have seen them, how they work. Therefore, these are the points which I am therefore mentioning for each one of you. And now, question comes how ICT comes into picture. ICT comes because, research in frontier areas is becoming more and more challenging due to vastly increasing literature in chemistry. Literature is becoming very vast. So how to deal? You may not have everything in your library. So ICT can help you. Electronic databases are becoming the real information source. They help you in literature survey, electronic databases. Electronic databases like a telephone directory. Using search engine, you can find whatsoever literature you want to search. And these are some of the most popular electronic databases. Scopus, you all know that. It is multidisciplinary, 71 million items. Web of Science, 100 million items. Science Direct, 16 million items. This is from elsewhere. ERIC, 1.3 million items. And then PubMed, which is in medicine, biological sciences, 30 million items. These are some of the most popular electronic databases. You can go to YouTube, just look for any one of these. It will tell you how to operate and how to use. Then, in this technology-driven world, you don't have to do everything with your hand. So many ICT tools are available. They have changed the way research is conducted. ICT, through its various tools, has totally changed the way research is conducted. Information sources, literature survey, data collection, data analysis, referencing, report preparation, even plagiarism check, everything can be done using ICT tools. These are some of the essential tools for research tools. You can just search any one of them, take the screenshot of this. So you can see how technology saves your time with the help of so many tools. That is the message which I wanted to give. And now I come to ICT in professional development of higher education chemistry faculty.
आगे बोले कैंसिल है एक हफ्ते से मैं फोन कर रहा बोले रहे तो इसके साथ मैं इसका भी कर डाला रहता ना
Could you please mute?
Please mute.
See, if you look at the professional development of the teachers, it started long back with academic staff colleges. Then came human resource development centers. Then came Pandit Madan Mohan Malviya teacher training centers. And now MMTTC has come, UGC-MMTTC. 116 such centers have been created in the country. Then we have the online programs, ARPIT, for chemistry people. Our center is the National Resource Center of Chemistry. This was launched in 2018, annual refresher program in chemistry. And we have already done many online courses. Just watch this video. This will tell you the level at which we have been operating in the country. Just watch.
Hello everyone, myself Dr. Vimal Raj and I am the coordinator of National Resource Center of Chemistry of MHRD, Government of India at SCTB Khalsa College, University of Delhi.
And myself, Professor A.K. Bakshi. We welcome you all to the ARPIT 2019, which is going to provide you a unique opportunity to learn as per your convenience. For
Specialization.
let's have a look at the variety of the modules which have been developed with the help of leading experts from all over the country.
To begin with,
we will have a special module as Chem News, which will bring the latest news to you from the world of chemistry.
The modules entitled Chem Talks will focus on the latest development as well as new and emerging areas of chemistry.
In the Chem Safe Lab modules, we will focus on various measures to be taken to prevent accidents in our chemistry lab.
In the module on Chem Nobel laureates, this time we will be focusing on life and contributions of Ernest Rutherford.
Through the modules titled Chem Pedagogy, we will highlight on improving curriculum development and question paper setting.
You will all agree that there are many difficult topics in chemistry. In the modules entitled Chem Simplified, we will take some of these topics and explain them in a very simple way. To commemorate 150th anniversary of periodic table in 2019, we have introduced in this course one module entitled Chem History.
Another interesting module of this online course is going to be Chem Industry, in which this time the focus will be on pharmaceutical industry and career options for our chemistry students.
In the Chem Error module, we will explain the correct usage of the SI units.
There are going to be some other exciting modules as well, like Chem Misconceptions, Chem Applications, Chem ICT Tools, and Chem Twist.
We request all the higher education chemistry teachers of the country to enroll in this online refresher course. At the end of the course, there will be a MCQ-based test. And if you qualify it, you will be eligible for points as well as promotion under the career advancement scheme of the UGC.
But dear colleagues, more important than points or promotional requirements, let us self-learn on lifelong learning basis and take our education system to greater heights. Jai Hind.
Jai Hind.
So you can see how this Arpit, it was 5 years back when we launched this. At that time, we are not talking about technology because it did not come in that big way, but now things have changed. And now I come to how ICT can help you in practical curriculum. Virtual labs have come. This is another area. Virtual labs this is the Government of India's initiative. Here it is the virtual lab through internet, various remote users can access and work. And this virtual labs project has been developed by all these IITs and various universities of the country. And all these broad areas are covered under virtual labs. Engineering areas, then you can see at the bottom, chemical sciences, physical sciences. All these are there now. For example, in physical chemistry, all these experiments are there, which you can do virtually. These are the experiments in the organic chemistry, detection of elements, separation of compounds, all those. And then in inorganic, these are some of the experiments, including various titrations and gravimetry. So you can see here also technology has totally changed the way practical curriculum is transacted. Virtual labs have come in the country. So that's a big development. But all what I have said about digital transformation, there are certain drawbacks also of digital transformation you should be aware of. In this digital transformation, there is a little or no face-to-face interaction. For example, I am delivering talk, you may never meet me. That way it is highly impersonal. It's mainly a monologue, like one size fits all. It creates a sense of self-isolation. That is a disadvantage. Then human touch is missing. Collaborative learning is not possible through online education. And then, All disciplines cannot be taught in online mode. It is limited to only few disciplines. And then too much time before the computer screen may be harmful for all of us. Look at these subjects: surgery, dental hygiene, sports, that you cannot learn in an online mode. They are difficult to teach online. Then there is a lack of communication skill development in online student. This is another serious drawback. And then, now so many courses people have started developing without any accreditation. The result is that the quality of those courses is compromised. That is why now it is being thought that in future, online courses may be coming with a grade by an accrediting agency. Oh, it is an A grade, it is a B grade, like that. Then computer illiterate people cannot access these courses. That is another disadvantage. And then there is a problem of digital divide. See, this problem could be, you may have access to device. You don't have the access to device. That could be one reason. Then you have the device, but internet is not available. That would also create digital divide. Then you cannot afford that. Then you have everything, but you are living in a place where climatic conditions are such that you cannot access. So these are the reasons for digital divide. And out of 4.4 billion internet users in the world, 600 million are in India, 40% in rural areas. World population is about 8 billion. Then more and more people are coming to use internet. And it is reported that by 2028, 100% of the world population will have internet access. So you can see then these courses will become very popular. And therefore, government is also making efforts to enhance the reach of digital content. There are now public digital libraries or information centers have been created. There are some subsidized internet plans. This is another way to attract people. Then you can waive off internet charges for the student. That is another approach. Then many governments are giving personal devices to the students, laptop, etc. Then existing mass media such as TV, radio, and community radio needs to be extensively used for telecast and broadcast. And then there are many educational programs which are available 24/7 in various languages. Because the aim is that all this content needs to reach to the teachers and students in their medium of instruction as far as possible. All these are the challenges in digital transformation. This was our article about, we trained when more than 45,000 teachers. Now we are nearing about 1 lakh. And now I come to the last part, that is the future of digital transformation. How the future is going to be. Please remember, technology in education is a journey and not a destination. And therefore, things will keep on changing. So where we will be in future, let's try to have a look. Just as look at these, how 5G has evolved. We started with 1G in communication, mobile technologies, 2G, 3G, now we are having 5G. So that is the evolution of technology. And then in our history, world, we had various industrial revolutions. Look at the first. We had the Industrial Revolution 1, then 2, and all these industrial revolutions came because of technological advancements. New technologies came which led to these industrial revolutions. And for every industrial revolution, there is a corresponding education system. Because the workforce for industrial revolution must come out of the education system. So please remember this slide. Industrial revolution, education system, and society are all interlinked. Because, each industrial revolution creates a system of education that addresses its needs. And this further brings about changes in society. So for Industrial Revolution 4, we will have Education 4, then it will lead to Society 4. That's the link. Then one could say, therefore, that technology is shaping education and society both. That's the message which you get from here. And now, many new technologies are emerging. Look at the picture, how the world will look like in 2030. Just look at that. And these are the technologies that are going to drive the change in future. Look at the top left, artificial intelligence, robotics, autonomous vehicles, self-driven vehicles, cloud computing, Internet of Things, 3D printing, quantum computing, biotechnology, augmented and virtual reality. These are the technologies which will change the future. Now, gamification is coming. Now, what is gamification? Gamification is based on the theory that students will learn better and they will attain greater success if learning is based on gaming concepts. What are the gaming concepts? Competition, incentives, and goal attainment. These are the gaming concepts. And many e-learning games are available in chemistry. You learn, you play, and you learn. So this gamification is becoming very popular. Look at these. These are some of the e-learning games for chemistry students. Not only that, these are some of the video games for teaching learning chemistry. And then list is long. You can go to any one of these sites, search them, and you will find how much is there to learn. Then, blockchain technology is coming now. Blockchain is a system of recording information in such a way that makes it difficult or impossible to change, hack, or cheat the system. A blockchain is essentially like a digital ledger. No editing is possible. And these are the benefits: greater trust, stronger security, higher efficiency, and transparency. See, in this technology, you can store academic data and records of the students. What is actually blockchain? See, blockchain is like a digital notebook that everyone can see, but no one can change. Imagine a book where each page has a list of things that happen. And once a page is filled, it is locked and linked to the next page. This creates a chain of pages, what we call them as blocks, making it necessary, nearly impossible to change them. That is how the blockchain technology works. It's tamper-proof, record keeping you can do. Then metaverse in education is coming. Metaverse is what? You are able to attend virtual classes, but you feel as if you are in the real classroom with the help of augmented and virtual reality. Because augmented reality adds digital things to the real world around you, whereas virtual reality puts you in a completely digital world through a headset. This is the new change which is coming. Then quantum computing is coming in the world. Quantum computers are very, very fast and efficient. And these quantum computers are based on what you have already read, de Broglie equation. Lambda is equal to h upon p, where wavelength and momentum are linked through Planck's constant. Because the dual behavior of the matter at microscopic level, which makes these quantum computers possible. And they are going to be very, very fast. Then world's fastest internet is now going to come. This Huawei company in China is coming out with the world's fastest internet, which can transmit up to 150 movies per second. 150 movies per second, just imagine. And the speed of the internet is going to be 1.2 terabits per second. Terabit is 10 to the power 12. If you look at our current internet speed, it is only 7 to 8 Mbps, 10 to the power 6. And there we have 10 to the power 12. So you can see so many new technologies are coming. And therefore, the future of learning in the light of these technologies is going to be very exciting. World is now slowly moving towards self-learning and personalized learning in the 21st century. Please remember it, self-learning and personalized learning. Self-learning is actually going to be the new norm in the 21st century. And there is a report that by 2050, 90% of the student population will be in online education. So what does it mean? Students may not be coming physically to the classroom in universities and colleges. Everything will be online. A big change. And this was the report in Times of India recently. Growing popularity of self-learning through free courses offered by IITs and IIMs on SWAYAM. Many people are attending so many courses. There are about 390 programs offered by IITs and IIMs. Students attend those courses online, earn credit, certificate, and diploma just by paying a nominal fee to the National Testing Agency. This is another change. Just imagine how the world is changing. Then personalized learning is coming. Even in chemistry, this is going to do a big revolution. Artificial intelligence is transforming the world. See, you should know what is artificial intelligence. First of all, what is intelligence? Intelligence is the ability to understand and learn or think or deal with new or trying situations. That is intelligence. Artificial intelligence is when you simulate human intelligence into a computer machine so that it can think and act like a human. Now, the difference between artificial intelligence and human intelligence is human intelligence uses their brain, memory, and cognitive abilities, whereas artificial intelligence system rely on the data provided by humans. See, artificial intelligence system will work on the basis of the data you give to them. If the data is wrong, results will not be correct. That is why it is said, without data, artificial intelligence system would simply lack the foundation it needs to operate effectively. And now what is happening? Personalized learning. Why there is a need for personalized learning? Because every learner is unique. Every learner has different needs, different interests, different comprehension rate. Learning capacity is different. So personalized learning is something like individualized learning. Like a doctor gives treatment to a patient, like here you will get a personalized treatment. So personalized learning is an educational approach that aims to customize learning for each learner's strengths, needs, skills, and interests. This is going to be a big revolution. So, now you can look at the whole history. The reality is that the learning process is no longer linear and one size fits all, as we have been assuming. That is wrong. In our teacher-centric talk and chalk method, we thought every student learned in the same way. That was wrong. The same thing is happening in online teacher, which is also teacher-centric using ICT. But now we are going to have personalized learning. You will get learning as per your needs, as per your interests. And how does personalized learning work? Artificial intelligence will collect data and analyze student performance data, provide educators with insights to make informed decisions, identify gaps, etc. So in personalized learning, every student will get a learning plan, which is based on what they know and how they learn best. It's a unique advantage which AI offers. This is going to be a big, big change. And personalized experiences will improve the performance of the students. And now, in the light of all that, what is going to happen to the future of teaching profession? Let's try to understand that. See, already people are thinking that technology is going to be a threat to the teaching profession. Some teachers worry that perhaps there will be no students to teach anymore in the near future because technology might take over teaching our students. Because now there are multiple sources of knowledge. So what will happen to the future of teaching profession? Already robot teachers are coming. These robot teachers developed in India They are AI empowered. Students ask questions in physics, chemistry, mathematics through commands, and they answer with 100% precision. They may replace human teachers in future. And then these are the advantages of robot teachers: always energetic, always on time, not making technical mistakes, such as marking learners wrong, then no favoritism because they don't have feelings or emotions. But please remember, human teachers will still be needed. Why? Who will tell robots what information our students need to know? Only human teachers. Only human teachers can give empathy and motivation to the students. Only human teachers can solve the disputes of the learners. Only human teachers can make learners feel better and like a doctor. So in the years to come, human teachers will also be needed because they can bring real connection, socialization, and creativity to the class. So what is going to be the scenario in future as a result of digital transformation? Teachers will be working hand in hand with robots. And that is the basis of Industrial Revolution 5. Humans and robots work together for more success. And even, MOOCs are going to change. The MOOCs which we have now on SWAYAM, they are like one size fits all. They are the same for everybody. But using AI, we may have in future smart MOOCs based on e-content 2.0. So what is smart content or smart MOOCs? Smart content will update based on who is viewing it. Keeping in view your interest, the MOOC will also change. That's a big change which is going to happen. So this is the history, how the world has moved from static content to smart content. Just note down, please, this is the most important thing. Static content was what? What we have in our books, textbooks, PDFs, which is a fixed content, unchanging, which can be printed. Static content can always be printed. Then comes e-content, which I showed, multimedia enriched, digitally interactive. And now we're going to have, in the years to come, smart content, which is adaptive, personalized, which will adjust to individualized learning needs. This is a big change. And in all these, teachers will have to change for their role. They will have to become ICT skills, AI skills. They should learn how to manage virtual classroom and discussion forum. So your role will be like a coach or a mentor. And you should be proficient in the development of e-content and MOOCs. You should have excellent writing skills. So ladies and gentlemen, I am closing, but remember, teachers will have to change with the changing times. This is the message you should take. And during last 6-7 years, world has changed so much. That's why it is said, change with the changing times or face the consequences. Look at this, Kodak company became bankrupt because it did not change and due to the emergence of digital photography. HMT, Bajaj, Dynora TV, Murphy Radio, Nokia Mobile, Rajdoot, Ambassador cars, slowly they are disappearing because they did not change with the changing times. This is my article about how Education 4.0 will work for coming generations. So the message is never stop learning. Inspire your students to be lifelong learners by being one. These are our newspaper report about our e-content. This is in Hindi. This is the MOOCs which we developed. This report came in Times of India. This is about our chemistry content when we launched ARPIT programs. This is another report. This is when National Resource Center of Chemistry was inaugurated. This is my editorial on the world of e-learning in Times of India. This is a Times of India report of end of talk and chalk regime. This is UGC MOOCs report in Hindustan Times. This is another article, why the Indian education system must focus on innovating its teaching approach. And then how to use ICT creatively in higher education. So thank you very much. It was a pleasure talking to you. And I have given you the best possible way where we started, where we are now, and where we are heading. And all this is happening in chemistry education. The way education is being imparted is totally going to change. So you should ready yourself for all these challenges. Thank you very much and all the best.
Thank you, sir. Now the session is open for discussion. Anyone want to clear any query? So please unmute yourself and you can ask.
Sir, how we can improve the scientific quality, the research quality in India? Like there,
Who is speaking?
I'm Harshal Patil, sir.
No, I can't. Can you just?
Mr. Harshal Patil.
Okay, please tell me.
Sir, how we can improve the research quality and the application of the research in India?
My feeling is, I don't know. I told you what all you need to excel as a researcher. See, in our case, I personally feel that in our country, thinking on the subject is missing. We don't have up-to-date knowledge in the discipline in which we are researching. We don't have a complete knowledge of recent advances in your field. You lack analytical, critical thinking skills and creativity. Because, creativity is connecting the previously unconnected dots. If you have a vast knowledge, you have done a lot of thinking on the subject, then you can come out with new ideas. In the absence of that, how can you do good research? You will be just dependent on your supervisor. Whatsoever he or she will say, you will have to do that. That is the reason we don't teach our students to become excellent researchers. We teach our students so that they are only the rote learners and get good marks in the examination. So all these things are required. The focus of teaching learning should change from rote learning to thinking, innovation, and creativity. And as I always say, the quality of an education system can never exceed the quality of its teachers. If you want to raise the quality of an education system, including research, you must raise the competence level of the teachers. Teachers should become more competent. Then looking at them, students will also become equally competent. That's what I feel is required.
Thank you, sir. And sir, I specifically wanted to mention that I have attended the ARPIT program, the Green Practices in Chemistry Laboratory. And this initiative the GAD-TLC took is very much updating the teachers of chemistry. And this access, easy access and flexibility, everything we cannot get without this platform actually. So we are getting more knowledge and we are implementing small things which we are learning, which is possible in rural area. Thank you so much, sir.
Thank you very much. Thank you. And Dr. Shah, I think we have already reached the time, so others are already waiting, so we can stop it. And others, whenever there is anything, they can always write to me or talk to me on my mobile number. Please.
Yeah. So, sir has given the contact details.
I've already given my
contact
contact
through the email
details.
or,
Many people write to me, talk to me, telephone me. You are always most welcome. Please.
Yeah. So thank you, sir. Most of the delegates has written wonderful and informative session and regarding these comments. The session will be more wonderfully informative if you incorporate all the things in your actual teaching learning process, whatever sir has covered. And sir has covered throughout his life experience. So this session was really nice and you have to impart. Sir, you started your session with the introduction of the ICT, how ICT tools can be integrated for the chemistry education. You covered the basics of the MOOC and then steps to develop the e-content that is statistics and that is multimedia content. and you also briefly told the 4 quadrants of the and format of the MOOCs. We focused on the good quality e-content development of the MOOCs in India, for example, SWAYAM and the SWAYAM Plus, and also introduced the National Digital University. You focused on how teachers can use the MOOCs to support the students, what MOOCs can do for India, challenges in the development of the MOOC, and science of learning. In the last part, in the later part, you discussed on ICT in the revision of the chemistry with multiple examples, challenges to the research, ICT tools in the research, professional and practical tools, that is virtual labs, focused on the drawbacks of the digital transformation also, and way to enhance reach to the digital content. In the last, you nicely told about the future of the digital transformation, emergence of the new technology, including the AI, robotics, cloud computing, virtual reality, and gamification. And lastly, you focused on the personalized learning, which is the need of the day. And you ended with the teachers will have to change with the changing environment. So thank you very much. I have one last question regarding that. You told about the SOYAM. So if we have already prepared videos on entire course of a particular subject, and you want to become a part of this SOYAM, how you can do?
See, it's now almost all the courses have been developed. But if you are interested in developing some e-content, we have also got e-teachers kit, which is a concept which we have started. Professor Vimal Rar has started that. You can talk to her and we will let you know. So many teachers are coming every day for developing e-content under teachers e-kit. So we can always discuss that, Dr. Sheikh. So thank you very much. And
Thank you,
I
sir.
can
Thank you.
see Professor Susan also and
Yeah.
Good
Professor
morning.
Viva also. After a long time, welcome to this program, Viva and Susan. And now I'm sorry it got little late, but now the stage is yours, I would put it.
Yes.
Good morning, sir. It's
Good morning,
always
Viva.
a delight to hear you and meet you, sir.
No, thank you. Thank you very much.
Thank
Thank you. Please, okay.
So someone is sharing screen or So good morning, everyone. I'm Dr. Vibha Sharma, and we start with the second session of the day. And we welcome you, Professor Suzanne John Verghese, Professor Suzanne Jason Verghese from Department of Chemistry, St. John's College, Agra. Just minimize this, right? So I hope you all can hear me properly.
Yes,
Hello?
you're audible.
Okay, so thank you so much. Thank you for confirming. And we welcome you, ma'am, on this platform. So, Professor Suzanne Jason Verghese is presently head of the Department of Chemistry, St. John's College, Agra. She did her MSc, MPhil, PhD, and she's been working in the Department of Chemistry since last more than 31 years. She has got PhD under her. Almost 11 research scholars got their PhDs, and 5 scholars are working for their PhD under her supervision and guidance. She has completed a project sponsored by UGC.
I think ma'am's okay. Thank you, Dr. Vibha Sharma ma'am, for introducing me to this audience and participants. A very good morning to all of you. And let me, before I start my lecture talk, I would like to thank Professor Bakshi sir for bringing me and give me an opportunity to get associated with GAD-TLC. Became instrumental in establishing a collaboration with St. John's College. And I also thank Professor Vimal Ra, ma'am, for always giving me and welcome me and gives opportunities and to upgrade my skill and give me a platform to wherever necessary. And let me start my topic today, and I would like to share screen. So can you see my Dr. Vibha ma'am, can you see my screen? Let me know, can you see my screen?
Yes, ma'am, the screen is visible.
Oh, yes, yes. Okay, thank you. So today I would like to talk to you. Already Professor Bakshi sir has talked to you about research, and I would like to enlighten you on research methodology and bibliometrics. And I would like to cover what is research and type of research and how to formulate a research question, literature review and its purpose, research design, data collection, data analysis,
Excuse me,
citation.
ma'am, your PPT is not visible. It's only the title, that is the desktop page, which is visible.
Okay. Is it visible? Not yet?
Not yet, ma'am. Not yet.
So I have to show your screen. I get.
I think you just double click on the highlighted research methodology PPT final, and I think you should get it.
Okay, ma'am. Then. Can you see, ma'am, now?
No, ma'am. No.
No?
Your probably the desktop screen is.
Okay.
The network
so
connection.
now.
I think you
So
log out.
okay, ma'am. Then. So I will just. Just a minute, please. I would like to. Shrudika, please help me to upload my presentation. So I am sharing my presentation with you. Shrutika, please share my screen. Please share my screen. Please upload my presentation. I have forwarded to you. So can you forward? Okay. I have forwarded to you. Please forward to Gayatri then. Please upload. Meanwhile, I'll just. Okay. Then now in few minutes time, my presentation will be uploaded for you. Without wasting time, let me about it. But again, I want to begin with what is research. Research is a systematic and organized process of investigating specific questions or problems to discover new knowledge, establish facts, and reach new conclusions. Again, the type of research from the perspective of application, we can classify research into pure research, applied research. On the perspective of objectives, we can classify research into descriptive research, exploratory research, correlational research, explanatory research, predictive research, and action research. On the basis of inquiry mode, you can classify them as quantitative research and qualitative research. So on the basis of application, we'll say pure research. What is basic research? Pure research is driven by a scientist's curiosity or interest in a specific question. The main motivation is to expand man's knowledge, not to create or invent something, and of course, there is no commercial value to the discoveries that result from basic research also. Simple example is, how did the universe begin? Or other simple example of basic research is, what are protons, neutrons, electrons composed of? Then the other one is applied research. Applied research refers to a scientific study and research that seeks to solve practical problems. It is used to find solutions to everyday problems, cure illness, and develop innovative technologies rather than to acquire knowledge for knowledge's sake. If we want to, in applied research, we can find out what is the reason for crippled knee and dental fluorosis for people living in a city or a state having high fluoride content. And that is one of the examples you can use. In the case in descriptive research, it refers to research that provides an accurate portrayal of characteristics of a particular individual or a situation. Hello, Shruti. To you personally, I have forwarded. Excuse me, please. Yes, Shrodika. Hello. Hello. Okay, I'll listen. So, descriptive research refers to research that provides Descriptive research refers to research that provides an accurate portrayal of characteristics of a particular individual, situation, or group. It is also known as a statistical research. These studies are a means of discovering new meaning, describing what exists, determining the frequency with which something occurs, and categorizing information. For example, an example of a descriptive research is finding the most frequent diseases that affect the children of a town. In the case of exploratory and history research, exploratory research is a type of research conducted for a problem that has not been clearly defined. It helps to determine the best research design, data collection method, and selection of subjects. Historical research is a research involving analysis of events that occurred in the remote past. For example, in the case of exploratory research, we can always ask why the problem of you say in terms of a disease or it's happening. You have to explore. But in the historical research, for example, you can say that how did the COVID pandemic happen? In correlation research refers to systematic investigation or statistical study of relationships among two or more variables without necessarily determining cause and effect. For an example, if you want to say the relationship between surface area of a solid reactant and the rate of reaction, for example, correlation between the surface area of powdered calcium carbonate and the rate of its reaction with hydrochloric acid, we get a positive correlation, which shows that larger surface area typically result in faster reaction. So that shows a positive correlation. That is an example for correlation research. Next is explanatory research. It is a type of research that seeks to clarify and deepen our understanding of complex issues by establishing relationships between variables and identifying causes and underlying mechanism. For example, we say that Yamuna water is polluted. That is a descriptive research. But in explanatory research, why it remained polluted and what are the causes? And why, how it always asked in explanatory research. Predictive research, it is a type of research focused on forecasting future outcome based on current and historical data. It uses statistical, mathematical, and machine learning models to predict how certain variables will behave under specific conditions, often without establishing causal relationships. The main goal is to identify patterns and trends that can inform decisions, strategies, and actions. Here, and this predictive analytics, I'm sorry I could not share my presentation, but I will ask my GAD-TLC technical team to share my PPT in your WhatsApp group so that you can go through again. And the predictive analytics, it is a statistical model, consumer behavior, machine learning, patterns, scoring, visualization, predictive behavior, decision-making, communication, it's important. But for example, in predictive research, we usually do the modeling. For example, you can ask that after 5 years, what would be the air pollution index of Delhi? Or what would be the availability of water by 2047? So again, the explanatory research. So in the explanatory research, it is a type of research that seeks to clarify and deepen our understanding of complex issues by establishing relationships between variables and identifying causes or underlying mechanism. That is what. Okay, in action research, it is a participatory and reflective research method aimed at solving real-world problems while simultaneously contributing to scientific knowledge. Unlike traditional research, where the researcher remains detached from subject, action research involves the researcher actively participating in the situation they are studying. It focuses on cycles of planning, acting, observing, reflecting, often in collaboration with others such as community members, educators, or organizations. In action research, for example, we collaborate with NGOs and find a solution for waste management of the city or a water pollution, how to control water pollution of the city, how to control air pollution of the city. That is what we do in action research. Now, in quantitative research, it is a research dealing with phenomena. Quantitative. Yes. Thank you, Gayatri. It is a qualitative research is dealing with phenomena that are difficult or impossible to quantify mathematically, such as beliefs, meanings, attributes, and symbols. For example, in qualitative research, we know that when an alkali is added to an acid, where phenolphthalein is used as an indicator, of course, in alkaline medium, it gives pink color. That we know it. That is qualitative research. Next slide, please. To qualitatively understand, next slide, please. Next is quantitative research. In quantitative research, it refers to systematic empirical investigation of any phenomenon via statistical, mathematical, or computational techniques. For example, here it measures concentration and distribution of microplastics larger plastic debris in a marine environment. Here we are quantifying. So for example, we can say that collecting water samples from different parts of ocean and counting the number of microplastic particles per liter the data is used to estimate total mass of plastic pollution in different ocean regions. So it can give you assess the scale of marine plastic pollution and to evaluate effectiveness of global initiative to reduce plastic waste. This is quantitative research. Next is research question. When we start doing research, of course, you know that earlier, now in according to National Education Policy 2020, the project is introduced from 5th sem onwards. So it is always, we have to tell the children, first you find what are the research question, like, before we choose a title or a topic to do, you question. For example, there are various research questions we can ask, like, does negative news interest people more than positive news? What are the factors motivating people to commit violence? Or do you think about the career options first before choosing education or careers? Which comes first or second? Do exercise improve the quality? We have to ask, what colors do red cabbage juice turn when added to different household substances like lemon juice, soap, or baking soda? Why do iron nails rust faster than copper nails when placed in water? Does soda go flat faster at room temperature when it is cold? Why don't oil and water mix, and how can you make them stay together? This kind of a small research questions we have to make. For example, an angle for your research can come from insights stemming from personal experience. You can use that as or you have some theory, some observations, contemporary issues, engagement with the literature, or you can use it, or a research question should be, like when we formulate the question, it should be clear, it should be focused, it should be concise, it should be complex, it should be clear. Clear ka matlab hai, why are social networking sites harmful? Clear, how are online users experience or addressing privacy issues on such networking sites as MySpace and Facebook? Which social networking sites, that is MySpace and Facebook? Type of harm, privacy issues. Who gets harmed? Users get harmed. These kind of clear questions we should form before we make the research. Ma'am, please, next slide. We have explained this. We are discussing about the question, and it should be focused. Focused means, what is the effect on the environment from global warming? That is unfocused. Focused question is going to be, how is glacial melting affecting penguins in Antarctica? That would be a focused question. So the question focus should be also so broad, can't answer in college level paper. Specific cause, it should be glacial melting, and specific place we should mention, that is Antarctica, and specific group affected we have to mention, that is penguin. Complex means it should be like, if it's too simple means, how are doctors addressing diabetes in India? That is a complex question. Appropriately a complex question is, what are common traits of those suffering from diabetes in India? How can these commonalities to be used to aid the medical community in prevention of the disease? Like, for a simple question, if you ask or you can find answer online immediately. But for a complex question, it requires significant investigation and evaluation. That is the difference between simple and a complex question. Ma'am, please, next is literature review. This is over, ma'am. I have a literature review. When you go for a literature review, the review of the literature comprehensive, in-depth, systematic, and critical review of scholarly publications, unpublished scholarly print materials, audiovisual materials, and personal communications. And it should be evidence-based. It should be sources that should not be related to the immediate concern or must be avoided, must be presented in your own writing style that conforms to the rest of the dissertation. Overall structure of the information must be uniform. Quotes are sparingly used in literature review, only when paraphrasing is not possible. Information from the source is limited to only the key points. Then what is the purpose of this literature review? This is to determine if proposed research is actually needed. For example, even if similar research published, researchers must suggest a need for similar studies or a replication. Narrow down the problem. It can be overwhelming getting into the literature of a field of study. A literature review can help you understand where you need to focus your efforts. That means what has been done and what you need to do. That is the gap that you will have to address. So generate hypotheses or questions for further studies. Background knowledge of the field of inquiry is needed. That is the others, what they have done, what are the parameters they have used, the most important ideas, theories, questions, and hypotheses they have used, and knowledge, what are the methodologies, and along with that, locate different type of resources they have used, decide which resource might be suitable for your project or a thesis, select most appropriate resources, revise research questions if necessary with your student. Ma'am, next slide, please. What is the purpose of literature review? The research cycle. Identify research area, design research study, and carry out research. Analyze your research results. Then you publish research results. Save the information. Keep a record of the literature you collect. Record where and when you retrieve the information. Determine if proposed research is actually needed. Ma'am, please, I have gone through this. This is how I explained just now, the research cycle. Save the information, this I have covered. Next slide, ma'am. Yes, research design and methodology. Research design is the master plan specifying the methods and procedures for collecting and analyzing the needed information. Research design step 1, literature search and understanding of the rationale. Step 2, identification of the key unknowns and research questions. Step 3, aims and objectives we should make. Identification of hypothesis, identification of hypothesis to be tested, and you have to do it before you submit, before you plan your things, and identify key deliverables, and identify key resources, and you make a time frame for your research, 1 year, 2 year. For a project, 1 year is available. Workflow model, you have to use it, and risk and what are the risk mitigation, you have to plan it. An idea for a research project or a thesis is formed. Next slide, please, ma'am. Research design, sample design. In this deals with the technique of selecting items that requires careful observation for the given research study. In observational design, this relates to the conditions under which the experiments are to be conducted. In statistical design, this concerns the question of how many items are to be observed, and how are the collected data and information going to be analyzed. And in operational design, this deals with the methods by which the procedures specified in the sample observation and statistical designs can be conducted. So again, in other ways, why you are doing the research, what are the key unknown factors, parameters you are going to identify, and determine the most important deliverables and locate important resources, research time period, make a workflow diagram, risk and how to avoid them, and start your research. Next is, ma'am, next slide, please, sampling. In sampling means refers to strategies and processes used to select individuals or unit from a population for a research study. It is very important and crucial because it is often impractical to study an entire population or entire problem. Selecting, we need a representative sample, helps researchers make inferences about the whole problem for a whole population. Why I say good sample? Good sample in any study or experiment, including chemistry, are essential for obtaining accurate, reliable, unbiased results. The sample should be a representative. To test lake water quality, a chemist collects samples from multiple locations and depth, not just the shore. If you collect the sample from the shore, it cannot be considered as a good sample. It should collect from various places, multiple locations. And randomness, a researcher studying soil contamination randomly selects samples around a factory, for example, reducing selection bias. Then adequate sample size. To measure air pollution, multiple air samples are taken over several days to ensure accurate readings. Homogeneity means a chemist stirs a solution before sampling to ensure even distribution of dissolved substance. No bias means a technician takes sample from various stages of production to check for impurities, not from the final product. Reproducibility means a chemist uses the same sterile pipette method at specific times in a reaction to allow others to replicate the study. Appropriate sampling method means a geologist, a chemist uses a coarse sampler to collect soil at different depth when testing for groundwater contamination. Timely sampling means a scientist or chemist collect samples at different stages of a chemical reaction to track concentration changes over time, especially when we perform chemical kinetics experiment. Next slide, please, ma'am. Steps in sampling design. Define the population. Identify the group or a system you want to study. Example, a chemist wants to test the pH levels of a large lake. The population is the entire body of water in that lake. Determining the sampling frame. Here, you have to specify the accessible for sampling. For example, sampling frame includes different location in the lake, shore, middle of the lake, different depth of the lake, and where samples can be collected. Choose the sampling method. Means decide how to select samples: random, systematic, stratified. For example, the chemist chooses stratified sampling, taking water samples from various depth, surface, mid-level, bottom to capture different conditions. Determine the sample size. That means decide how many samples are needed to get accurate, reliable data. Example, The chemist plans to take 50 water samples from various locations and depth to ensure the result represents the entire lake. Then similarly, collect the sample, analyze the sample, evaluate and report results. Because lack of time, I have to wind up my talk at 11:40. So I'll just, ma'am, next slide. Types of sampling, types of sampling. Sampling methods may probability sampling methods are there, non-probability sampling methods are there. In probability sampling, simple random sampling, systematic sampling, stratified sampling, cluster sampling. But in non-probability sampling methods, convenience sampling, quota sampling, purpose sampling, snowball or referral sampling are there. Next slide, ma'am, please. Next slide, please. In probability sampling, simple random sampling, systematic sampling, stratified sampling, cluster sampling is available. Next slide, ma'am. In non-probability sampling, convenience sampling, purpose sampling, snowball sampling, quota sampling methods are there. Next slide, please, ma'am. And data collection is one of the most important stages in conducting research. Qualitative and quantitative data. Next slide means process of data collection. Define the objective of a survey and experiment. And define the variable and population of interest. Defining the data collection and data measuring schemes. Determine the appropriate descriptive and inferential data analysis of the technique. Next, ma'am, it's a variable. Next slide, please. Variable matlab a characteristic about each individual element of a population or a sample. And two types of variables are there. Next slide, please. Qualitative or an attribute, or a categorical or variable. In a quantitative variable, that is numerical, cannot be counted. A variable that categorizes or describes an element of a population, color, smell, quality. But in the quantitative, arithmetic operations such as addition, averaging are meaningful for data resulting from a quantitative variable. Next slide, please, ma'am. Nominal need of data collection to get information for analysis, to get idea about the real-time situation, for comparison between two situations. Next slide, please, ma'am. Methods of data collection. There are primary and secondary data. In the primary, surveys, questionnaires can be formed. You can interview and conduct an interview, and you observe and make an experiment. But in the secondary data collection, you can do the literature review also. Government database, you can use it. In commercial database, you can use it, and along with web scraping. Ma'am, please, next. Data analysis. Data analysis involves the systematic application of statistical, logical, computational technique to describe, visualize, summarize, and interpret data. It is used to discover the patterns, trends, relationship within data to help inform decision making. Define objectives. Start by understanding the purpose of analysis and the questions you aim to answer. Data collection. Data analysis, exploratory data analysis, use descriptive statistics like a mean, median, mode, etc., and a visualization like chart and graphs to explore the data and understand patterns. Statistical analysis, apply techniques such as regression analysis, hypothesis testing, correlation analysis to examine relationships or predict trends. Data modeling is create models, machine learning models to predict or categorize future outcome based on historical data. Interpretation, summarize findings, draw conclusion, and make recommendation based on analysis. Visualization, communicate insights effectively through chart, dashboards, and reports. Next slide, ma'am. Descriptive statistics versus inferential statistics, unveiling key differences between these two. Next slide, ma'am. The process of data analysis, reality, raw data collection, data processing, and data cleaning, data analysis and models, insight, visualization, and data product. Next slide, ma'am. It's about the citations and references. References are essential part of academic writing and research and data analysis. They allow you to credit the original source of ideas, theories, data, and other materials used in your work. In academic context, references ensure the integrity of scholarship and help others trace the evolution of ideas in a particular field. Ma'am, next slide. Next slide, please. Books, journal article, conference papers, websites, and online sources, reports, database, thesis and dissertations can be used for references. Next slide, please. Reference patterns you can use for literature, emerging trends, influential authors and institutions, cross-disciplinary influences, you can use it. Next slide, ma'am. The popular citation styles we use are, especially the journals now ask, are American Psychological Association, where, for example, how we write in reference, authors, year, title of the book or article, journal or a publisher, volume, pages, and from this to that page, and DOI and a URL. This is the method. Next. This is one of the way of writing. And next is modern language association. Here, especially this is used in humanities, literature, and arts. For example, authors, title of work, title of container, other contributors, versatile number, and other version, and the number, publisher, year, and pages. Example is given below. And next again, one more, next slide, ma'am. Next slide, ma'am. Again, this is a model language association, how we use it. That is an example of it. Next, ma'am. Next, ma'am. This is the tools for managing references, reference management software, Satoro, EndNote, Mendeley, BibTeX. Citation generators are Cite This For Me, Easy Bib or Citation Machine, usually be used. Next, ma'am. Best practices for references are constancy in writing, accuracy, plagiarism prevention. Next slide, ma'am. What is plagiarism? Next slide, ma'am. Next slide, ma'am. These are the books used. Plagiarism in research methodology involves the unethical use of others' research method. Design appropriate without proper citation or acknowledgement. This type of plagiarism can compromise the integrity of scientific research and mislead readers about the originality and rigor of study. So, ma'am, I would like bibliometry. I won't be able to touch now. These are the plagiarism detection software used. Turnitin, Grammarly, and can use Q-test review. And Quillbot, Scriber, this thing, bibliometric, I won't be able to touch now. So the ma'am, next slide, please. So this slide is out for me. 11:40 was my time to wind up. Professor Vinidhi Gupta, ma'am, is already joined, and next she will be taking her delivery now. So these are the bibliometric data. You can just, this is what I prepared. I could not explain much because it all needs explanation, research methodology, citation metrics, and how we calculate the journal impact factor, and total number of papers and journal impact factor, benefits and limitations, helps in measuring the influence of research, aid in identifying top researchers of influential work, limitations, may not account for quality over quantity, citation, also do self-citation. Next slide, ma'am. Yes. So predatory, then I would like to wind up here, ma'am. Professor Vibhasha, ma'am, stop sharing my presentation. Thank you. Thank you.
Thank you.
Thank you so much, ma'am. And we are extremely sorry for the technical glitch in the beginning of the session.
No, ma'am.
But,
I am also sorry for, I could not share.
No, even at my end also, there was some problem initially. So very sorry. I was reading your write-up. I don't know whether you could hear it. Yes.
Okay.
And if we have any questions before we start with the next session, so
Dr.
yes,
Vibha, we
please.
will take questions at the end of the session.
Session.
Okay, with both the sessions, fine.
For lack of
So
time,
then I'll
ma'am.
share my screen again.
Stop sharing
Yes.
them. Thank you. Thank you.
Thank you,
So
Dr.
should we
Susan. Thank you, sir.
introduce ma'am first?
Thank you.
So, okay, let me introduce ma'am to all of you then.
Please close the presentation.
Ma'am, I would like to introduce you first. I
Yes,
hope
ma'am.
it's fine.
Okay.
Okay.
Yes, please go on.
Yes. So our third session is on fostering early research in higher education through interdisciplinary collaborative projects by Professor Vinati Gupta, Professor of Chemistry at Shri Tikaram Kanya Mahavidyalaya, Aligarh. We welcome you, ma'am, on this platform. So, ma'am is currently Professor of Chemistry at Shri Tikaram Kanya Mahavidyalaya, Aligarh, and she's been teaching for the last 25 years. She has done her graduation from Dyal Singh, Dyalbag Educational Institute, Agra, MSc and doctorate from Agra University. Her research area includes soils, pesticides, green solutions of water purification, chemical education, and organic chemistry. She has undertaken minor research projects sanctioned by UGC CSIR on the studies of biocidal properties of organic formulations as an alternative to chlorine and for purification of water. She was awarded for academic excellence by the Hindu Girls Education Society and felicitated by MHRD Minister Srimati Smriti Malhotra Irani for individual achievements and service to the nation in 2016. She has been a member of American Chemical Society since 2012 and is a regular presenter of her student-related activities in undergraduate classrooms at the Biennial Conference of Chemical Education, BCC, which is a wing of ACAS. To date, she has presented 10 projects of her work at undergraduate levels, and which has also led to publication of chapter in ACS Symposium. And she's also has in the book Using Food to Stimulate Interest in the Chemistry Classroom, published by American Chemical Society. Ma'am has 14 publications in international and national journals, and one is under communication. She has been continuously working on gender in chemistry education. Thank you, ma'am. Thank you for joining us, and we look forward to hear from you. Thank you.
Thank you so much, Dr. Vibha, for giving my introduction. At the very outset here, I would like to thank Professor Bakshi, Professor Vimal Rar, for giving me this opportunity to be here with all of you. I thank my institution and my principal, Professor Sharmila Sharma, for giving me all the facilities to give this talk. And a most important thanks to my department of chemistry at this college and my colleagues, Professor Sangeeta Kumar, Neha Kamal, Surbhi Vashne, Palak, and Sakshi, who have been with me throughout while I've been preparing this presentation. So let me share my screen first. This is screens. So this is the screen. This is the application window. How do you get to the screen here? Select a window. So why shouldn't my screen be visible here? My desktop should be visible here.
Yes, ma'am, it should be visible.
Please, is Gayatri here? Why is not my screen visible here?
Gayatri is not here, no.
Then,
So that's why we were having problem in the last session also.
just a minute. Let me, yes, please. Why is the screen not visible here? Yes, yes. Okay. So is my screen visible?
Yes, ma'am. It's visible.
Am I audible clearly to all my participants?
Yes.
So my topic today is, as you can see, it is fostering early research in interdisciplinary collaborative projects in the UG and the PG classes, which has been incorporated by the NEP 2020. I am Professor Viniti Gupta from the Department of Chemistry at Sri Tikaram Kanya Mahavidyalaya. Now, this is a very important quote from Sidney Sheldon, a prolific author, and he says that there is magic, but you have to be the magician, and you have to make the magic happen. So, if I put forward to you this, that the young minds have lots of ideas, lots of motivation, but they need the guide, the advice, and the support and help of the teacher to actually get those ideas to reality. So that is what we feel by the phrase that we have to act as a magician and we have to tap the magic within the minds of our students. Now, this is a very fast course credit I'm going to tell you that in NEP we have the degree in the Bachelor of Science, and we have a research project in the 5th and the 6th semester, which is of 3 credits. Then we have a research project in MSc in the semester 7 and 8, as well as semester 9 and 10. And these assessments in PG are both internal and external, whereas here in the BSc, the assessment is totally internal. So now the advantage and the need for this research project is that, as you all have been studying throughout this refresher course, Bloom's taxonomy has been shown to you time and again. So again, I will refer to this Bloom's taxonomy, and I would like to here tell you that the lower orders, that is the remember and understand, are the classroom contents. That is, these are the things we teach the students in the class. But apply, analyze, evaluate, and create are the higher order thinking skills. And through a research project, we expect that our students will start cultivating in them the higher order thinking skills. Now, this is a Venn diagram through which I would just like to touch on the student-centric outcomes, which will happen because of a research project. See, the knowledge base increases, and when the knowledge is applied, the skill base or the development of skills take place. If a student starts practicing skills, it is but natural that the student will have a lot of confidence, and that will promote a lot of intellectual curiosity, the confidence, the comprehension, and the student has more scope to study further. If the student does student progression, academic progression happens, then there will be professional development. But a research project is not only student-centric. A research project has a lot of outcomes for the institution as well. If all departments of an institution work towards good researches, naturally an institution will have a good knowledge ecosystem. And it can also function as skill development centers for specific skills. Now, if our institution, if you create an institution with a specific skill, you will definitely be invited by the industry or by other institutions to share your skill. So this promotes industry and academia interactions. And if this happens, then our institutions will start working as incubation centers, and incubation centers, which will be showcasing their work to other institutions on other platforms, and we can start a startup center probably in our institutions, which presently is a very far cry. Now, These are the broad program outcomes of a research project in chemistry, which are defined by our university. And as you can see, these 6 points, only the first point is related to classroom content. The remaining 5 points are all related to the higher order thinking skills, designing experiments, critical thinking and reasoning, exploring new areas of STEM, defining the role of chemistry in a society and applying to it, and also functioning as an interdisciplinary problem-solving team. The course outcomes for the UG level research project, as defined by, again, our university, are research methodology. Dr. Susan has been talking about it. Due to time crunch, she could not discuss much. So research methodology, research ethics. Yes, research ethics is very important these days. We have to give the credit to the person who has done the original research. Research gaps, excuse me. So the research gap is that when we read literature, when we read publication, we learn to see what work has been done and then what work needs to be done. So this research gap can only be identified if there is a proper research methodology or there is a proper literature review. The students need to be taught about data analysis and academic writing. Now here, when I say academic writing, all of us are aware that our students are very lacking in writing skills. So here, a well-structured and a knowledge base needs to be created. A knowledge base can be random. A knowledge base can be random, but here the stress is on a well-structured knowledge base. If the knowledge base is sound, the student will actually develop certain skills. Now, these skills may be team-related, they may be individual. Critical thinking, problem solving, that is all hurdles. If they come, if you have a problem, there should be an attempt to solve a problem instead of making yourself stationary at that point. Time management is very important because in a semester, they have to finish a project, or in 1 year, if a project has to be completed along with other courses, then time management is very crucial and needs to be defined very clearly. Collaboration. The students have to work in teams. We all have a huge, what you can say, bulk of students in UG classes. So collaboration projects help us in just involving each and every student in a research project. Presentation skills. These presentation skills may be PowerPoint presentations, but presentation skills is also to present your problem, present your difficulties, present your issues to your faculty and your team. Promotion of knowledge and skill sets will actually promote personal growth and academic excellence. The student will be confident, there'll be intellectual curiosity, the student will start referring to books and to data around, and we really expect the student to go forward in studies and not be a dropout. The course outcomes for a PG level research project is slightly more in depth and more knowledge experienced as compared to the undergraduate project. So here we expect each student to be very individual in their knowledge experience, advanced research methodology, expertise in a research area. They should be now thinking, not validating a research already done, but trying to contribute to some original research. Now, the data analysis techniques to which they have been introduced previously, they can move on to further like SPSS or ANOVA regression analysis. And yes, they should be aware of theoretical frameworks and designing theoretical frameworks before their project. These skills are very unique to a researcher. Independent research, the confidence to undertake independent research, confidence to critically evaluate the knowledge one gets from literature review, the problem-solving attitude, communication with the peers, communication with the mentors, and a strong ethical sentiment, which is just not touching on plagiarism, but yes, creating your own work and giving credit to the person whose work you are citing. Now, professional career will occur if there is research leadership. There is networking. A person improves on networking. If you discuss your issue with others, you will get a good feedback. Then there is career advancement and a temperament of lifelong learning. Now, how does a student get these characteristics in UG and PG? So the task lies with the mentor or the faculty. The mentoring includes coaching. The mentoring includes training. The mentoring includes support to the team members, the students. And if there is well-defined coaching, well-defined training and support, the success should follow. Success means the outcomes which I have put forward for my students, I should be able to see that success. That means for all this aspect of coaching, of training, support, we need assessment at all points. We need assessment of the coaching, we need assessment of the training done, we need assessment of the support, and only then can we assess the success, the level of the success. Now, I would like here to tell you about my college, that I teach in a women's college. And though my institute is in an urban setup, we have girls from rural and semi-rural areas. And many of them, majority, are actually first-generation learners. There is no educational environment at home. So, as you have just seen my profile, we have been studying gender bias in girls, and majority of these girls are facing gender issues at home. So there is a level of stress which is very palpable in their personality when they come to college. So all the time, our thoughts are that we do not have to increase the stress of the student. But if this NEP introduces a research project, I would like to put this slide forward that yes, we have to prepare our students for stress and management of stress. Because unless or until students optimize their performance, they will not reach the specific aim which they have defined for the research. So important thing is to prepare students for stress and management of stress. And here I would like to show you, this is, these are the pass out students. So these students worked in a team. So since we also have started research projects since last year, we realized that when we create a group of students who understand each other, who feel encouraged and supported by each other, it is always good to bring them together. So these students share responsibilities, and this helps them to reduce the stress which they otherwise feel. They do collaborative activity. There is input of all members, and the workload is evenly distributed amongst the team members. So there is no burnout, and there is no discontent. This is the thing, this is actually the slide which Professor Susan was talking about, that in a team, the students have to undertake a research project. So in this, while they are at it, they have to do a literature review. They have to identify keywords. They have to refer to academic databases, reference management systems. They have to have data collection techniques, documentation of their work, findings and discussion. And after all that, only can they do an abstract writing. Now, how will they do all this? There is a lot of knowledge deficit. There is a lot of infrastructural deficit. Many students do not have technology at home or in college. So how do they go about it? So we have to actually introduce our undergraduate students to the concept of a research problem. What is a research problem? They need to be introduced to that you have to identify a problem. Now, even if they give us a random topic that, yes, ma'am, we would like to do something on that, we have to tell them that this is nothing random. It all needs a systematic investigation. You need to read something about what problem you're going to deal with. So it might be new knowledge, it might be an existing knowledge within your subject area. The most important thing is brainstorming. And for this, team meetings are very important. So we have to also tell them that you take time in defining your research problem. You have to choose from the options which are given by your mentors. We give them options, or you can take your own problem. But whatever you do, you have to go about a systematic investigation. So we actually give them time to define or to arrive at a research problem. Now here the problem is presently not defined. They have only arrived at what they would like to do. So we tell them that you give a talk on the significance of your problem. Why do you like to do that? Why would you like to do that in your research paper? And ultimately, when all suggestions are given to us, we listen to them and we organize the suggestions so that we help them define a clear research problem. Defining a research problem needs reading of published papers. Now, reading of published papers, again, needs internet presently, because all colleges do not have a very well-equipped library. So, and the movement is restricted due to a lot of academic work going on in colleges. So the dependence is mainly on internet. So the literature review or the reading of published papers has to be done on the internet. We provide students with the computer, the desktop, which is in a department. And majority of the students do have mobiles, but still some do not have. So the group which you should create should always be of a mixed category, where there are students who do not have mobiles and they are in a group which is a very proactive or a prolific group, so that the group activity, no one suffers in this group activity. Arriving at a research problem also can be done when the students consult their parents at home, or their colleagues, or the mentors, or if they approach us and we can introduce them to experts in the field. So by this way, they clearly articulate the core issue. I mean, they start understanding what they want to do. And we also tell them to refine your research problem, change your research problem, improvise it, and revise it if necessary. So iteration and reiteration is important. And this helps the student in defining a clear research problem. It is really important to introduce students to websites and portals like a UGC care list, ORCID IDs, Indian journals, UGC approved journals, EPG Pathshala, Mendeley, National Digital Library, InflipNet, Zotero, and Google Scholar. All these websites have their own purpose. Zotero is a reference management system. Mendeley is a reference management system. These are journals in which students can look for publications. ORCID ID is a very unique ID which a student needs to register and would be asked by publications or by platforms when they become a teacher in future life. Now, what has to be written in a project report? The student in UG is absolutely clueless, so we have helped them arrive to a research problem. Now, once the problem statement is defined, they have to write a project report. Now, if they have to write a project report, it is a lot similar to what we write in a research paper. But yes, here the methodology and experimental work will also include all the trials. It will not only include the successful trial, it will include all the trials which failed and which helped them go to the next stage. So synopsis or an abstract with keywords, body of introduction in which the research problem is justified and the literature review is organized, the methodology in which the experimental work is documented, observations are recorded and collected, the data is collected, and the students can also add pictures or videos of their work. The data needs to be analyzed. It can be through statistics, a chi-square, or a correlational analysis. But in the PG, we expect them to use proper data analysis techniques. Discussions and interpretations, that is analysis of the data you have documented. And this is actually with the help of the mentor. Interpretation of results and the references. Just like Professor Susan mentioned, we have types of references sequence, that is the APA, the MLA, the Chicago, etc. So these all aspects have to be taught to the students at the UG level. And this then helps them to draft a project report. Now, like I said, each aspect of coaching, training, and support needs to be assessed. So how can you assess the work of a student so that none of the students falls through the crack and we are able to assess each and every student? So for this, we use project-specific benchmarking, which we use in our college. And I would like to introduce what we do in our college. And you can, if it suits you, you can modify it and you can use it in your institutions. So the advantages of this framework of benchmarking is that the primary advantage is that the mentor satisfaction is immense. And if the mentor satisfaction is immense, it will actually improve the efficiency, the quality of the work. It will improve the learning methodologies. It will improve the competition amongst the students. The weaknesses will be reduced, and it will ultimately result in the improvement of the institution. So mentor satisfaction is very important. You should be very satisfied that you have judged each student properly. You were not dependent on your individual observation. You have documented the observation for all to see. Each colleague in my department will do this benchmarking for myself and for others. So there is immense mentor satisfaction in this type of benchmarking, and each student is totally analyzed while they are working on a project, and that is the formative assessment and the summative assessment. That is, the formative assessment is also very much justified, and summative assessment is also justified. A lot has been written on this slide. I request you not to read what is written on this slide and just focus on the picture which I have put here. And here, like I would like to tell you, is the purpose of benchmarking. Now, this is one aspect on which we have 4 students who are on the 2nd, 3rd, 4th, and 5th position, and 1 student is at the top. But it is not necessary that this student is on the top in all parameters. In some parameters, the 2nd student might be on the top, and in some parameters, the 4th, the 5th student might be on the top. So the purpose of the assessment is only this, that you have to identify the strengths of each student. Please do not focus on the weaknesses, but please focus on the strengths of your students. So now, how do you focus on the strength? By comparing it with a benchmark, with an established benchmark. Now, that benchmark is not only your own. That benchmark is defined by the department, by the faculty members in consultation with team meetings. This PSB helps us to identify our gaps for improvement. Now, what we do is we can monitor students' progress. Formative assessment. We can monitor students' achievement. Summative assessment. So in all these assessments, we have a monitoring teacher effectiveness. How effective was teacher in giving the students the directions? How effective the teacher was in giving them a support? Availability of that teacher and the demand of the student. So these teacher effectiveness monitorings are very important, and the visible aspect of this is that if we see our students engaged in a research process, it is a clear indication that the teacher effectiveness has been positive. We have to decide on the monitoring of infrastructure and resource allocation. If we see that the resource allocation is invested is less and the student achievement and the outcome is good, that means the research project has feasibility. That research project is sustainable. If the input or the resources we have put in is huge, but the outcome is not so good, we really have to give it a thought about how to curtail on our resources. Because here I would like to tell you that the university or the institution does not allocate resource presently for research projects at UG and PG level. So from where does this resource come? It comes from us. So we have to actually very categorically define on the feasibility and sustainability of a research project. Another important thing which the student has to monitor is one's self-evaluation. Self-evaluation is very important, that the student should know how much you have contributed to the growth of this project, how much you have contributed to the progress of this project. And then that also helps that the peer members also can give a feedback about each other, about the mutual contribution of the peer members to the research project. The slide here shows, the picture here shows that we do not have to stagnate at only one time. With every assessment, you will see there is growth, there is more clarity in your perceptions, and there is more refinement in your research project. I really love this picture of chemistry because it tells me a lot about color in chemistry. So benchmarking in chemistry is very important, and this is all about chemistry. So let me come to the benchmarking part. So as a trial, we all give research projects to DST, DVT, UGC for getting a project sanctioned. Now, I have seen that many of my colleagues here do feel a handicap in filling up a research project. So because they have not been introduced to it. So we drafted a small research proposal format for UG. This is actually very innocent, but if I may say, the students do have a problem in writing an abstract. Because their writing skills are not important. They have difficulty in writing a research gap. And the third thing is that they have difficulty in giving a budget or writing what raw materials they need, or why would we need to travel? Why is madam writing traveling expenses? So the rest of the form is very comfortably filled by them, but they do have issues in writing these three aspects. This gives them an insight about what they have to write. So we have seen that when they write a research project for the PG, they are much equipped to certain queries. This is a UG research proposal for a PG group, and this is only for our department reference, and we keep it, and we can actually revise and iterate for the next session. Now, based on the benchmarking, what are the parameters for assessment? So the assessment starts at the very outset. How unique is the research problem? Are the students validating existing knowledge or they are searching for new knowledge? What are the techniques they are using for assessment? Are there the hackneyed old techniques or they have search literature review and are bringing out a new technique? They are free to refer to YouTubes also, let me tell you here. So this is actually important, and the assessment starts from here. Is the problem they are working on related to the environment? Is it per the BIS standards? Has this work been done in any area before, or in a college, or in the city, or in the area? And before doing all this, has the infrastructure in the department or the college been assessed or taken into consideration by the team? How clear is the data collection? The qualitative and the quantitative, as Susan ma'am mentioned, and whether it has been appropriately documented. The result and the finding and the publication and the citation metrics. The research and findings and the publication and citation metrics are these two aspects where the mentor has to really put in their best to help the students arrive at a result. The result is not necessarily be a novelty, but it can definitely help them in the potential impact of the society and the environment. The publication and the citation metrics, the peer review process, all needs mentorship and guidance to the group. And actually, after this assessment, we have seen that the results of the project are really positive and good, as I will show you from my case studies in the future slides. The rubric for the assessment of the research project paper is on these 4 parameters. Let me tell you that if the individuals, if it is a group activity and we have to assess an individual in a group activity, it is very important to ensure fairness. And this is a very tricky task. This is not easy. This is very tricky. So you have to be very particular in each and every aspect that none of your students fall through the crack. Remember this, none of them slip through the crack. The parameters are drafted so as to evaluate each student in a group project. And we communicate these assessment parameters to the student before the project begins. This helps the student to understand our expectations, and this helps them to focus on individual contributions. So this is a self-assessment feedback. This is a mentor observation feedback, which the mentor does, that is during the formative assessment. This is the mentor assessment feedback, which the mentor does the summative assessment. Now, this is of 2 kinds. For the UG, this is only internal, but for the PG, we have 2 feedbacks, one from the internal faculty and one from the external. The peer group feedback is that the feedback is given by each member about the other members of the team. So these are the Google Forms which we give to our students, and I thank my technical hand, Palak, for always being ready to create a Google Form at the shortest time behest. Now here I can also show you the Google Form. Sorry. Is my screen clear?
Yes, ma'am, we can see it, but it's not on the full screen mode.
Sorry?
It's not on full screen mode at present.
Oh, yes, it's not on full screen mode. I'll put it.
Yeah.
So this is the assessment of students. So This is a 4C, that is in the rubric of assessment. This must be on the 4C point. And we can fill in a Google form. The students can just click and they can fill out a Google form. So indicates a question. This is the preamble and the session which we need. Now, yes, I have filled, so I can go to the next slide. Now, I just want to give you just an idea that the student participation in a research project on a scale to 1. Now, how actively, so the student has to individually self-assess. Like assessment of students is basically the, I as a mentor will decide on each student, how did particular student assess. So there are 5 students in a group. So I assess this for each student. Now, if I assess this for each student, I share it with the student. Now, if this, the student communication and collaboration, this is for each and every student. And we also give the skill and knowledge work on the rate or scale of 1 to 5, and the skills, and then we can finally, and we might not have filled the question, okay, and I can go to the next and I can submit. So these are the, what you can say, the Google Forms about the peer group members, the assessment of teacher effectiveness, self-assessment form. This is sent to the teachers on individual mails, on their individual emails, and this is the assessment of the student by the mentor. Assessment of teacher effectiveness is sent on the emails of the students, and here they can actually fill in for the teacher and give it back to us. Now, another rubric for evaluation is this. So rubric for student assessment in a research project paper is my screen visible to you? So based on the feedbacks, we can evaluate and give a rubrics that what is the name of the student, how was the attendance, what was the insight, the ideas, the level of effort, completion of assigned part. And here we can actually, depending on the feedback, give our ratings, which can be assessed, communication and collaboration. So the name of the student, effective communication, active listening, leadership quality, group support, the skills and knowledge, again, the research aptitude, the problem solving, the technical skills, the critical thinking skills, which we have assessed in a Google form, they can be documented here. The individual reflections, the self-assessment form, the group peer feedback form, the mentor observation form, all these 4 combine to give this rubric, which we have combined in the 3 tables. This gives a very clear picture of the student, and we are not now marking or assessing a student on our observation or on our bias. It is clearly for all to see. Apart from that, we have the assessment methods in which the review of work is for 100 marks. So the review of work can be internal in case of UG and internal as well as external in the case of PG. So here I also have rubric for evaluation of research project. So rubric for review of work is that research question and methodology, the clarity, the literature review, the methodology, the data collection, findings and discussion, presentation of the findings, discussion with the researcher, limitations and future research, overall coherence, that is the finding, the discussion and the conclusion coherent. How was the writing of the project report? Was the writing clear, concise, or it was beating about the bush? How was the style? Did the student adhere to the styles which were discussed by us? The citations and references, and also the overall presentation. Was it visually appealing? Was it neatly bound, well organized? Then contribution, this is actually done by the external, which is novelty. They are able to better decide on it. The novelty, the significance of the findings, the theoretical implications, the practical implications, institutional implications, the societal implications, and the overall impact. So these rubrics need to be worked on. And like I said, that so much of assessment goes into a research project, and it is very sad that at the UG level, this is not part of the external evaluation. This is totally internal. And this is mandated to get a degree. This is a very complicated file, let me tell you, slide, because here we have Google Forms. Then we have to assess the Google Forms and tabulate and put it in a rubric. So if you have any doubts or you need these, you can contact me on my email. I'll be happy to share and help you out with your work. The ultimate finding after doing so much of activity since last 2 years was that there are 3 essential components to assess a student in a group activity. So that each student is, there is a tab on each student, there is a tab on each mentor, and there is a tab on the research. So the tabs are threefold: the quality of the work, the quality of the mentor, and the quality of the student. So team meetings are very important because team meetings lead to good inflow of ideas and thoughts. Action plan is very important because it leads to the success of a project. If there is no action plan in place, you cannot monitor the progress of your work, the progress of the research work. Assessment is very important so that the assessment is not only mentor sensitive. The observations of the mentor is not alone. You have to be accountable for each assessment which you have done. So these are the 3 essential components for assessment. So this is an Excel sheet. I have taken screenshots of all the projects which were conducted by the UG program last year. This is thanks to my head of the department, Dr. Sangeeta Kumar, who is absolutely meticulous in her documentation and precise in her allotments. So thanks to her that we have this list with us. And now this year, if you see, the number of projects in our chemistry department have increased. So this itself shows teacher effectiveness, and our assessments have been appreciated by the students, and the students are actually eager to take up a project in chemistry. So there definitely has been learning, there has been a mentor effectiveness, and there has been good progress in the research work. Now, let me bring to you the case studies. This is the manufacturing, testing, and sale of rose water, which we have been undertaking in our college since last 3 years. Initially, we did it before COVID, but after COVID, we could not take it up initially because of low student presence in the college. But now we have started since 2-3 years. So the rose water manufacturing, testing, and sale is a project which was undertaken by the undergraduates, but now it has been actively taken up by the postgraduates. Now, since we are selling rose water, we cannot depend upon the fractional distillation alone. So we have to opt out on simmering methods. Due to short of time, I'm really sorry I could not label each slide, but I'll try to rush up and tell you that this is the slide which required ice because this was simmering method, and we made rose water in the month of March. And simmering methods, if they are conducted in winters, they might not need ice. There was the sale of rose water in December. We are actively selling rose water on the demand of the consumers. We have already a good consumer base regarding rose water. And here two outlets in the city have actually shown interest in showcasing our products on the counters for sale. The students are regularly participating in conferences and institutional innovation council meetings and showcasing their work. So the testing of rose water for pathogens is being done by students. This has been done. Now, plant extracts are very good, are very popular as alternative medicines. And so, since they are plant extracts, they can be easily contaminated with pathogens or microbes, which can affect human health. So the students undertook a pathogen study, and they took a freshly extracted rose water, 1 week unrefrigerated sample, 1 week refrigerated sample, and 1 month refrigerated sample. So the 4 samples show that if you can see my cursor, there is good colony bacterial growth on the agar plate, agar sterile plates. The dilutions were made for each, and this shows that the commercial rose water shows a good pathogen colony development, that is both gram-negative and gram-positive bacteria. Whereas this slide was 1 week unrefrigerated samples, and the other 2 samples, the fresh water as well as the 3 and 4 samples, did not show any growth. So we stress here that keep our rose water in fridge refrigerators, and then there should be a process to monitor the sanitization of packaging material wherever necessary. The testing of rose water for composition is underway. We can only do composition testing by LCMS or GCMS. And by these methods, only 3 tests can be identified. That is the presence of ethanol and methanol, which is only present in rose water, which is naturally made. In synthetic, there is propylene glycol. Then the essential oils, that is the citronella, linalool, and geraniol, the ratios are higher of C/G in rose water, which is from natural methods. Then the phenyl ethyl alcohol content is much high in natural, and it continues to increase as the rose water is being processed, and is very, very low in what you can say, the synthetic variety. The characterizations of these compounds will be done by the group in this semester on LCMS, for which we will have to take our students to Aligarh Muslim University. This is the second project which is being conducted by our institution. This is the manufacture of soya and the beeswax candles. Now, we do not use paraffin wax for manufacturing of candles, and we are totally relying on the plant and the animal wax for candle manufacturing. So again, we are manufacturing and we are testing them and selling them. Now, this project is our main source of revenue generation. What I here would like to tell you that, like I said initially, that no university or no institution provides any resource allocation or infrastructure to conduct a research project. So I would suggest that devise techniques so that there is research, so that there is revenue generation in your department, which you can use for conduction of a research project. Now, before Diwali, as Diwali is approaching, this work is in a very hot phase in our department. You can see the different colors. The students are using food colors. The students are using very vibrant food colors, which are very safe for use. The students also came across this idea, and the mentor in charge also gave them an idea that you can use lipsticks. So the students are getting discarded lipsticks, which are also consumer safe, and they are using those lipsticks to give the pink color to the candles, as you can see here in the picture. Here the student is pouring hot wax into paper mold, and then you can see the candles which are being made. The students are using paper molds, and they use also the plastic molds, silicone molds for making candles. The candle here at least burns for about 4 to 5 hours. And the minimum testing which we actually do is, we have not done major testing in the candles, but yes, we put an inverted terracotta pot to see the carbon generation. And let me tell you that the carbon generation is so minimal that it will definitely help us do further research studies on this. But primarily, this is our main source of revenue generation presently. Project which is underway is organic droop cones. Now, this is a tough project because here the students wanted to make organic droop cones and they are ready to take up challenge. So, using dried cow dung, dried flowers, camphor, activated charcoal, resins, the students are preparing droop cones. Initially, they wanted to make incense sticks, but incense sticks is a very highly cost-effective project. So through our research, through our sale proceedings, we could get this mold for droop cones, and I suggested that they can make droop cones. So here you can see that they have measured and they are preparing the dough, and then through a mold, they are preparing the droop cones. Here they are put out for drying. This is a burnt out droop cone, and this is the packaging and selling and presentation. Now, let me come to this part, which is the part of the resins. On study of manufacturing, preparation of droop and incense, we came across this in the literature reviews that the joss powder or the jiggat is used as a resin for binding the incense. This is an extract from a tree which is found in the northeast Indian areas and is on the verge of extinct. Consequently, it is very expensive. So we floated this idea to our students that instead of focusing yourself on joss, let us find alternative resins for binding of your droop. And we came across this guar gum, which is actually a gum which is isolated from beans, the guar ki thali. So we have a lot of resins from plants. That is, we get it from the ladyfinger. We get it from what you call the lisoda or the labera. I don't know how many of you are aware of it. We get it from the beans and gum arabica, which is available. But then we had to see the feasibility of the whole research project. This is cheap, this is easily available, and this is used in extremely minute quantities. This also helps in the binding and the proper burning of the droop cone. You can see the droop cone is completely burnt here. Do you think that it should come into your mind that is this environmentally safe? It is, because the carbon which is burnt is just on the top of the cone. It has not disintegrated or it has not been taken up by the environment. So this can be easily slid and put up in the mud for fertilizer purposes. The three cones here are that this yellow one is plain without any aroma or any additive. The green cones have the bitter gourd leaves in them to give them green color, and the brown ones are the cones with sandalwood powder. The students have also used gugal. They have used loban of frankincense. They have used samagri, havan samagri. They have incorporated all these ingredients in different types of droop cones. This is the packaging which they have done and sold, and they are also participating regularly in the Institution Innovation Council meetings. The problem before them is the analysis of the toluene, benzene, and formaldehyde, that is the VOCs and fumes of the droop cones made in the project. Now, they have to do all this study, and these studies, some have been done but the synthesis methods of nano-sized ferric oxide-based catalysts, the reaction mechanisms, the utilization of the iron waste to modify, this all work has to be done. And on basis of all this, the assessment for all these projects is being done. Another research project is underway is the handmade cold press soaps, which are 6 weeks cured and a pH of 8.5 to 9. Again, manufacturing, testing, and sale. You are all seeing this, that all the projects we are doing presently, not all are giving us a remuneration, but majority are giving us money for which we can carry over future research projects. So the soap needs lye, that is sodium hydroxide, oil. The students are taking coconut oil and olive oil, and this is the water. The three main components being the lye, the oil, and the water. The students have to take up water discount into consideration. They have to take up the saponification value into consideration, saponification value of coconut oil and of olive oil. They can even make a soap using the Rickert-Meisel value, but the best is the saponification value because we are making a soap. So we can use sodium hydroxide and we can even use potassium hydroxide. But in the lab, since sodium hydroxide is easily available, we prefer lye to potassium hydroxide. Considering on this, these three factors, we have to consider this, that this soap will be used by people on their skin. So for that, we have to take a consideration of superfat. Superfat means that we decrease the quantity of lye by marginal amounts. And then we also have to consider the water content, which should be again at a minimum. So for this, the values are calculated as per the saponification, and all values are taken in grams. Here, the students are adding a lye solution to the oil with the help of a blender. The reaction is occurring, the saponification is occurring with the use of a blender. Here, the students are trying the turmeric soap. They are in the process of making a turmeric soap. This is an extract which the students made. They coarsely blended and they squeezed the extract in a, what you can say, muslin cloth, and they have used this to prepare a soap. Here the students have the last week, the students have made a coffee soap. They have used coffee and they have prepared a coffee soap. As you can see, the pH of all these three soaps are between 8.5 to 9. Now we start taking the pH values at the stage when the soap is, the reaction is taking place. We take the pH value once the soap is made, and we take the pH value in our hands when the lather is made. So we see that the pH value continues to decrease as the curing process occurs, and we refer to different citations and literature review for the skin-related issues which have to be taken into consideration. Now, this is a very nice research project which was undertaken by our postgraduate students, the extraction techniques and chemistry of bioethanol from waste potato. Just like the farmers are taught about vermicomposting and they take it up as an alternative profession, the farmers in Kannauj are being taught about essential oil extraction, and they take it up as a new profession. Similarly, this method can be taught to the farmers and they can use this as an alternative means of business. Now, waste potato is, if you can see, many cold storages throw waste potato, which has been spoiled in the cold storage, and we see it lie wasted by the side of the roads. If you go via what you can say Sadabad, in this area of district, and we see a lot of waste potato which is there. We can actually extract bioethanol from that waste. It's a very simple process. You have to collect that potato, clean it, and boil it. Once boiled, you mash it, add amylase digesting enzyme. Amylase is available in two ways. You can get amylase tablets also from the market, or you can make amylase by growing grains of wheat and then mulching the wheat germ and putting it in the potato pulp. Amylase, the wheat germ has a high percentage of amylase, which can actually digest the starch. After this, the pulp or the slurry can be boiled for 40 minutes or 50 minutes till we ascertain that all the starch has been hydrolyzed and has been converted into sugar. This is the Benedict's test for the testing of sugar, which shows that the slurry has now the sugar content. Once this happens, we add yeast to the slurry, and this slurry then is kept aside for a week before we get a highly activated yeast. And this solution is then fractional distilled at 78 degrees. We get ethanol as a pure solvent. Now, you will be surprised to know that this collected ethanol is giving perfect tests for ethanol. We can test for ethanol using potassium dichromate and sulfuric acid, where we get a green precipitate of chromate. We can also add a pinch of sodium piece to ethanol, where it will give us hydrogen bubbles. And both the tests are positive. This is a very interesting slide of making paper from sugarcane bagasse fiber. That is the sugarcane waste. So making paper from bagasse is a very important exercise, because here we are checking on the carbon footprint. The paper, if paper is made from plant waste, we don't need to cut trees to make paper. We don't need to have deforestation to make paper. So the sugarcane waste can be obtained from all those vendors who sell sugarcane juice. The sugarcane bagasse fiber is treated with sodium hydroxide. It is then blended and then put in a stencil to make paper. The students tried about 4 methods. They tried to make 4 types of papers. One was with sodium hydroxide without heat. One was with heat. One was heating for 1 hour. One was heating for a longer time. And one was also a paper which they tried to make without sodium hydroxide, just by mulching. So this is the paper which they made without sodium hydroxide, and it did not give good results. This is the paper which they made using lye, and they got a very good paper. This is the actual photograph of the paper, which I'm showing it to you. Then tests were conducted on the pH of the paper, the water absorption content of the paper, the biodegradability property of the paper, and the grams per square meter, the GSM quality of the paper. For this, the students did a pH test. They made specific sizes, 2 by 2 centimeters of paper were cut, and they dipped that in about 5 ml of water to 10 ml of water and kept it overnight. And the next day, they studied the pH of the water using the pH meter. For the water absorption test, they did a similar thing by cutting the paper and putting it in water. Now they took the initial weight of the paper and the final weight of the paper, and they got the percentage of water absorbed in each paper. And this is the graph they have reported for it. The biodegradability test was done by burying the paper strips in soil, putting water and in a wet soil, and observing that after about 1 week. So the original weight of the paper and the reduced weight of the paper gave the percentage error. The GSM values, this is a formula that the GSM can be calculated by weighing the paper and then multiplying it by a value of 10,000. So basically, if you take a size of the paper, 2 by 2 centimeter paper, you weigh that paper. So the weight of that 2 by 2 centimeter paper into 10,000 divided by the area of the paper gives you the GSM. So this study was conducted, and here again, I would like to suggest that these two projects, that is the paper making and the bioethanol, have very good potential for farmers. The analysis and testing of paper was done, and here are the water controls which were made by the students, the different papers which they made. And a study of the fillers is also very important, because the students have to add a filler to the paper, and the filler might change the paper integrity, might change the total property of the paper. So a study on the fillers, evaluation of microbes need to be done, because again, they are plant extracts, and microbes can, or pathogens can develop on the paper over a period of time. So they also need to do a study on that. Now, this I would like to tell you that chemistry can be blended with just any discipline in your search for a research project. And here, you yourself as teachers know that interdisciplinary research gives you valuable knowledge and valuable skills. And who knows, you might land up doing some groundbreaking research. So you can do research in materials science and chemistry. You can create nanomaterials if you have a microwave in your department. We can investigate materials for efficient energy storage, biocompatible materials. If we study environmental chemistry, like we are doing projects on environmental chemistry, we can develop environmental friendly chemical processes. This Professor Sushmita Chaudhary has already been talking about it, and so has Professor Sarita Pase. And we need to develop similar processes in our laboratories. So actually, we are also in the process of preparation of aspirin via a green pathway. So we are trying to not use sulfuric acid, and we are finding alternatives to sulfuric acid by using citric acid or tartaric acid, or even lime juice or tamarind juice. So let us see what happens. Then removing pollutants from air and water. Now, pollutants can be removed by bioremediation or by phytoremediation. That is, we can use microbes to remove pollutants. We can use light to remove pollutants. So we can also have a project on investigative methods. The study of drugs, manufacture of biofuels, and analysis of proteins and genes. A work can be done on exercise or extraction of DNA, RNA, tissue cultures in laminar flows. That can be undertaken. Computational chemistry. We have had extremely amazing lectures on molecular modeling, and the present staff and faculty which has taken charge is really good in molecular modeling. So you can really take up molecular modeling and designing of new drugs, then analysis of biological samples and poisons. This is actually a very interesting part, and I would actually like to undertake a project, but being a girls' institution, we have restrictions and it's not easy. So you can analyze drugs or poisons, chemical analysis for crime at crime scenes, and investigating trace amounts of substances. All can be done in our research labs. Here we have historical chemistry. We can combine history and chemistry. So you can study chemical weapons during World War. We can study the chemical compositions which we use to preserve historical artworks and artifacts, like what is being done at the Louvre in Paris, or the balming of mummies in Egypt, the studying of chemical substances used in religious ceremonies. Why are we using cow ghee? Why are we using mango woods? and their cultural significances. Sound and chemistry. Yes, there is an important relation between chemical relation and sound chemistry. We use foam bricks to check sound. So what is the purpose of a foam brick? How does it act? What is the reaction happens when a sound hits a foam brick? Music and chemistry. How chemical changes are associated and how does it have a therapeutic effect on our brain? So music therapy. Analyze chemical compositions of various musical instruments and understand their tone and durability. Here, I would like to say that a research shows that majority of the chemistry lovers are very fond of music. So I conclude my talk here with a thought from a very good motivational book by Richard Bach, Jonathan Livingston Seagull. At one time, it was my personal favorite. It still is. I haven't read it since a long time. And here, Richard Bach says that don't believe what your eyes tell you. All they show is limitation. Look with your understanding, your mind, and find out what you already know. And you'll see the way to fly. And let me tell you, you'll fly very high. I have all my wishes for all of you. A very big thank you to all of you. And here is my email. If you have any doubt, anything which you would like to ask me, you are free to ask me, and I'm open to questions. Here, I would like to stop my slide sharing, and I'm open to questions.
Thank you so much, ma'am. Thank you. So now if you have any queries, any questions, you can write the chat box or you can ask, ma'am. Unmute yourself and ask. So otherwise,
email, I have given it. It's very simple, vinithigupta@gmail.com. My email is there. I'll put it in the chat box. If you have any questions regarding assessment, due breaks of assessment in a research project, if you have any doubts, you're just open. And if you need any support in your research project in your institution, you can anytime contact me. I can even give you my, you can send me it by email or on my WhatsApp. So please do not hesitate in just opening your wings and flying out. You can unmute yourself and ask any query you have.
then you can message.
Please ask the team to unmute. It will be better if the participant asks me,
Directly, yes, that would be better, definitely.
Yeah. The GAD team, the TLC team, I request the technical team to please unmute the participants. There is no one from the technical team presently?
No, ma'am, there is no one.
Oh.
Yes.
Could you call someone and ask them to
Or they can message to save time because they have next session also. So
yes, ma'am.
Chat box, yes.
Okay, so I'll just put in my mobile number. You can give me a call.
Ma'am, how do we take care of reputation generated?
Sorry, how do we care of? Yes. So let me see the question first. How did you take care of the revenue generation? So see, what we do is that let me take the case of soaps or let me take the case of candles. Now Diwali is fast approaching. So what we do is we have manufactured soaps. Now, once from tomorrow onwards, the Nau Durgas will be starting, and there'll be, everyone here in the northern part of the country and the southern part. I don't know about the southern part. The northern part keep fasts and do regular prayers. So they are on a buying spree. So during this time, we try to sell them products. We actually put stalls in our college. So we put stalls of the dhoop cones, the soaps, not yet, the candles and the dhoop cones, and the rose water. So we try to put them at a minimum value so that our expense per bottle, which we calculate the expense of the product per bottle, we calculate the expense of one candle, and we calculate the expense of one dhoop cone. On basis of that, we create the price of the box. So the students do not take anything for their work. Their labor is free. So what we do is we sell them and we get that amount back. Now we put it in a common, proceeds. The proceeds are in a common box, and we continue to support our research projects on that basis. Have I answered your question? I hope so. Yes. So I'm opening the chat box. How do we take care of the revenue generated? It is actually totally in the hands of the department and in the hands of teachers. So if we maintain a register, so if we take out about, let me say, 500 rupees from the kitty, I have to note it down. And the purchase of that 500 rupees, that bill is attached into the register. And we continue to monitor our purchases, and then we consolidate this at the end of the semester and before selling the product. And then we manage the remuneration generated. Now, it's about synthesis of soap. Yes, Dr. Owais Ahmed, I hope you.
Yes, that has been taken care of.
Is smell of rose water does not change after a long time. Here, let me tell you, Dr. Mohsin, that if the rose water is pure and natural, it will have an extremely faint aroma and there'll be no color. If you find that the rose water you have purchased from the market has a smell, let me tell you that there is an additive to it. So, okay, so you take a break. I'll thank you, ma'am. Thank you, participants.
Just to answer participants that we are asking the team with respect to break time, that if they can extend it by 10-15 minutes for them.
Yes, ma'am. I'll just ask the team.
No, I have message to them, so it's fine, ma'am.
Okay.
So, any other question? Any other query? Okay.
You all have micro teaching, so my best wishes to all of you.
Let me
give a
put
very
my
good
vote of thanks
presentation.
also for you, ma'am. And this is for Professor Suzanne also. In fact, both of you complemented each other in terms of your topic of research and giving us such invaluable inputs. So thank you, Professor Viniti Gupta, for your highly informative session on fostering early research in Indian higher education. And I would say that this is not just for our students, undergraduate or postgraduate. This is applicable to many of us also as faculty members. Sometimes due to unavoidable reasons, after our PhD or maybe postdoc, there is a time gap and then it becomes very difficult to pick up research. So both of you guided us so well to take up research at any point of time from any scale. And initially, if faculty gets into it, then definitely we will involve more and more students also into it. So thank you. And the topic actually is so vast, but still you try to cover it in a very concise and with valuable slides here. And especially the part where you highlighted the importance of involving academics and industry in terms of collaboration. because this will definitely lead to many startups, and many of our students would be in a position to participate and take up these startups in future. And I also appreciate your way of telling us how to involve our students as a group of mixed, say, backgrounds. So that would in fact help them to learn from each other from different backgrounds here. So thank you so much. And we will definitely be in touch with you and look forward to more sessions from you. Thank you, ma'am. On behalf of
Thank you
all,
so much. All the best to all of you.
thank
Thank
you.
you so much.
And
Thank
to
you.
put on record, very grateful to Professor Suzanne also. So we'll write to her. Thank you so much. Thank you, ma'am. Thank you. So thank you, participants. I'm sure that you will get to hear through your group, through WhatsApp group, if they are extending your session. So I hope that they do give you 10-15 minutes extra, right? So thank you so much. Thank you.
Dr. Vibha, should the meeting be ended for all?
So yes, from my end, I can just say leave meeting, but you will have to end, ma'am, for all.